This
Nothing
conference will now be recorded.
I just want to understand a layman criteria. For example, if my mom is going to ask me, beta, once you are done with physical design course, what exactly you are going to do? If you become a physical design engineer, what exactly you are going to do? If that is the question, I can't tell her like after synthesis we'll do this. She will not understand anything, right? So a layman criteria, a very basic question I'm asking. If you want to make others understand what exactly is done in physical design. So one person has told we design the component. Chalo, I agree to that part. Other, so this whatever you answered, that is technically okay, makes sense. I don't want to enter into technical right now. You got my point?
Yes, sir.
So अगर मैं एक word में बोलूं, if I want to say in single word, can I say that we make chip IC? Normal word में. So if my mom is going to ask, we will say like I just make chips. So if I say chips, she will be like confused with chips. Okay, is it a potato chip or what? So I need to tell her like, see what. So if I want to give a basic example, I will tell that see in your mobile you are using memory card, right? So such kind of chip that is actually electronic component. So we make that in physical design. At the end of the physical design, whatever the flow is there. So that is what is the final product. Correct? This way I can tell her, right? You got my point?
Yes, sir.
Okay, so basically what we make ICs, and IC is the acronym of what? Integrated circuit, correct? So if I ask you what is this integrated circuit, so just help me with this. What is integrated circuit? Now go in technical if you want, not a problem. So if I ask you what is a circuit, if I tell you what is a circuit, so what comes in your mind? What picture it makes? See, if I say apple, so suddenly a picture of apple will come, right? So similarly, if I say what is a circuit, what picture come in your mind? Just think once.
So electronically connected components.
Which something like this will come in your mind. Maybe
Yes.
you would have solved some circuit. Something this will come in your mind, right? If I
Right.
go in more deeper way and I want to make you more realize it in a real world. So everyone has done breadboard experiments in their BTech and MTech, right? There will be breadboards, right, where you will find that a lot of such kind of holes will be there, and you will connect your wires here, right? And that wire you will connect to the components. Like they will say like one ohm of resistor you will connect it here. Maybe some kind of cap you will connect here, capacitance. So such kind of connections you will make, and finally you will connect to some 5 volt of battery. Correct? This kind of circuitry you have seen in your BTech and MTech curriculum.
Yes, sir.
Everyone has come across this thing, right? So this is a circuit. What is a circuit? When there is an active element and there is an energy source. Active and passive elements are there, and an energy source is there. So when this is formed in a closed loop, then it is called a circuit. Correct? Everyone is getting this?
Yes, sir. Yes,
Everyone is
sir.
getting this? So what is difference between integrated circuit and the normal circuit, if I ask you?
So when we talk about the integrated circuits, that means we are having the various circuits connected together.
So various circuits connected together. What do you mean by that?
Or you can say different chips or different ICs on a in a layman language.
So different ICs or different chips you told. So this point we will discuss later. Okay. So we'll come again. So yeah, I ask you what is difference between integrated circuit and a normal circuit. So any other answers? Only C is answering or others also will answer? Everyone is going to pay for this course, right? Or only C is going to pay? Are free of cost? Okay. Yeah, go ahead. What is difference between integrated circuit and normal circuits?
Integrated circuit means system on a chip. Like on single chip, everything is there.
So see, this is what you told. Okay. And then normal circuit? So देखो, what is the difference between a normal circuit and integrated circuit? One simple difference is there. Okay. Sorry. Anyone want to speak something? I'm giving time. Okay. So let's say someone is there. I will catch someone. Let's say Raju is there. So Raju, if I tell you, Raju, you are able to hear me?
Yeah. Yes.
Okay. So if I tell you, Raju, can you give me 1 ohm of resistor or 2 ohm of resistor from this circuit? So whenever you are doing an experiment in your BTech or MTech curriculum, in the breadboard, on the breadboard you would have assembled some kind of resistor, capacitor, or FET or something like that. So if I tell you just give me 1 ohm of resistor, you can give me or not? You can take out and give me, right?
Yes.
Okay. Now if I tell you you have a phone, right? Which phone you have? Let's say any phone. So let's say in that Snapdragon processor is there. So if I'm telling you from that processor, can you take out and give me 1 ohm of resistor? Can you do that?
No, not possible.
You can't do that, correct? So the difference is when active and passive element, they are in the discrete form here, okay? Here it's in discrete form, okay? Don't confuse with discrete circuit. It's a discrete form where you can take out this component. And here what is happening, all the active and passive elements are fused together on a single surface. So all active and passive element fused together on single surface. Abhi, it's like a very simple language. I'm telling single surface, but if I want to go to technical term, or maybe I can say a single die, and in future when you will understand, I will tell about the wafers. So is it clear till here? So integrated circuit and the circuit both are same only, because anyways active and passive element will be there, and you want to carry out some kind of algorithm, that will be done. But the difference is in circuits there are the discrete element which you can take out, but in integrated circuit all the active and passive element are fused together on a single surface, that you can't individually take out. Is it clear? Is it clear? Can you please mute yourself, everyone? Okay, fine. I'm audible, right?
Yes, sir.
Okay, guys, one small thing.
sir.
See, you can talk. If you start speaking for 1 minute also, that will disturb me for another 2-3 minutes, because I will tell you a very simple thing. My flow is very different from other trainers. I don't have any PPT. PPT is there. I will show you the PPT. This is the PPT given by VLSIGuru. I can go through and walk you through this PPT. But believe me, I never from past 6 years, I am taking all the classes and all. I never use this. I will use at the end of the session. You will understand why. Because my demonstration is purely on current scenario. Whatever you will tell on based on that, everything will go forward. So if you disturb me, the flow will break. Please don't mind, but this you need to keep in mind. And you are mature enough. Yeah, everyone is BTech and MTech, so have some maturity on that. Okay, so now coming to this part. So see, this is the way we rule out in the interviews also. Someone has told like SOC, different ICs and all. These are like purely different thing. See, for example, if you say different SOCs, what do you mean by SOC? System on chip, right? This is what you mean. See, when you make a integrated circuit, do you think that it's a multiple system on chip? It can be possible, but you have used like some ICs like IC 7432, you know. This is OR gate, right? If I'm not wrong, it's been long term. Just let me know. It is OR gate, right? IC 7432.
Yes, yes, sir.
So in OR gate, can OR gate perform any other operation apart from OR gate?
No.
So it's specifically made for one single type of operation, right? So that will be called as ASIC, application specific integrated circuit. You got it? You got it?
Yes, sir.
So assume that there is a chip that is a ALU. Now ALU will be able to do addition, subtraction, or let's say this is a calculator chip. So it will, inside calculator ALU only will be there, but in calculator you can do a lot of operations, right? So that will meant for multiple operations. Okay. So that time I can think that okay, that is like multiple kind of operations are happening there. So maybe it is a system on chip. I'm just giving a rough idea. It is not exactly the same, but you got the difference between system on chip and ASIC. So you can't tell like integrated circuit is system on chip. So integrated circuit exactly is not a system of chip. System on chip is a type of integrated circuit. You got it? Is it clear?
Yes, sir.
So that gives
Yes,
my
sir.
first answer of first question, which I was expecting from you guys. So once you are done with physical design, you are going to make the chip. Final product will be like what? Maybe a chip, a IC, a black color, some golden plate or something like that. ये होगा आपका final product. Correct? This is the final product. Correct? So if someone tells you like what you are going to do once you're done with physical design, so you need to tell them I am going to make the processor, or I am going to make any sensor like Snapdragon. It's a processor from Qualcomm, right? Or maybe CPU processor that Intel make. Okay. Similarly, some graphic card. All these things come under the chip, integrated circuit. Is it clear now? Is it clear
Yes,
now?
sir. Very clear. Yes, sir.
Yeah,
Very
yeah,
clear.
sir.
But do you really think that fabrication happens in India? What is a fabrication? So fabrication is the process of finally converting this. I mean, let's say map is there where I'm telling that here you will place the register, here you will place the capacitor, something like that. And based on that, I'm going to really make the chip. This is a kind of fabrication. Those steps and all I will teach you later. But do you really think that in India fabrication happens?
No, sir. In
No,
India,
sir.
we do not have any fabrication company.
Seriously? Seriously?
No, I think it
I
in
think in
Bangalore.
India
We
one
do have
foundry is there.
fabrication in India. We do have fabrication in India.
Very good. Where, yeah?
We have.
Chandigarh. Chandigarh, huh? Semiconductor laboratory, SCL. So India had once, I mean, it was long time back. It was actually operating semiconductor laboratories in it's in Chandigarh actually, and they were doing project of ISRO and DRDO on higher tech node. But after that, they have moved it for mostly for research purpose. And now, since you would have seen like Modi government has actually said that they are going to invest 76k crore, and even the latest news before 1 week only it has come like in Mysore they are going to set up one fabrication plant. You guys know that 22k crore they are going to invest for one of the fabrication plant in Mysore itself. So
Yes,
India
sir.
is going to get the fab houses. Okay. So in reality, till now, I mean, still in an upcoming 2-3 years also, we are not going to fabricate the chip. So fabrication was never a part of, I mean, our industry, Indian industry. So what exactly was our role as a PD engineer? So we give the best physical design engineer in this world in India. Indian engineers are best physical design, you can say that, but they don't really participate in the physical fabrication process. So now also the question still remains like, so we are not going to make the chip, right? That is what I'm saying. I'm not going to make the real chip. Physical chip I can't make and give you in your hand, right? So what exactly we are going to do as a physical design engineer? Okay, so we are going to discuss
We are
that.
the designers.
We'll discuss that. We are the designers. We'll discuss what kind of designers. Can we discuss that?
Sure, sir. Sure, sir.
Okay, okay. So I hope till here everything is like at least you got an idea, right? Okay. So I'm moving forward and trying to make you walk through this flow or how actually the industry works. I'm trying to help you with that. So see, when I talk about the integrated circuit, as I have discussed, right? So integrated circuits, when we make, we need some fundamental building block, correct? And what is that fundamental building block? With that, the chip will be made. An IC is made of what? Don't tell me silica and don't tell me wires. I am asking about the component. Like if you want to make a home or a building, if I ask you component, you will tell me like brick, cement or something like that. The same way I see a building block, what it is. What is the building block of an integrated circuit?
Transistor.
Perfect. Perfect, right? Transistors are the fundamental building block of any chip. Okay. So now when we come to like what kind of chip it is, like I told, like adder, subtractor. Similarly, I talked about the ALU, right? Similarly, I will talk about the SRAM, DRAM. Maybe in future I will tell you about the processor, Snapdragon. I told, right? Diamond City, there is other processor. So all these I will name, right? So now you will be like confused, like what kind of chip it is. So there are like based on complexity of transistors, we actually categorize the integrated circuit in various families. Okay, clear enough? So based on complexity, the division is something like this: SSI, small scale integration. Then you will have like MSI, medium scale integration. Then you have LSI, large scale integration. Then you have VLSI, very large scale of integration. Then you have ULSI, ultra large scale of integration. Any doubt in this? Naming you can write it here. I mean, you can Google and get it, everything. So it is like roughly you can see like if 10 and 100 number of transistors are used, then I can say that this is falling under the categories of small scale integration. Clear enough? And maybe some 100 to 1000 transistors are there, then I can say that it's like medium scale integration. Like more than 10,000 or something like that component is there, I can say that yes, it's in LSI. Okay. And then when it comes to like millions of transistor, I can say that okay, VLSI. And when it comes to jillions of transistor or billions of transistor, then I can send ULSI. Is it clear till here? So basically this is I mean more or less similar only. So VLSI is something which is like right now ruling over the industry, because we don't actually rely on a smaller component a lot. Okay, so we mostly have like devices where more number of transistors are fitting in a small space, right? You got it? Everyone is getting it?
Yeah, sir.
Yes, sir.
Getting it? So we will be
Yes, sir.
focusing on VLSI. So what is the full form of VLSI? I just told anyways.
Very large
Very
scale of
large
integration.
Very large
scale
scale
integrated
of,
circuit.
हाँ जो भी
Oh,
होता
भाई.
होगा यार. I'm just writing it.
Why?
Okay. Okay. Hello. Someone was something. Okay, fine. So very large scale of integration or very large scale integrated circuit, something is there. I'm not interested in that English jargons. Just it is like integrating transistors to a large scale to make a component or make an IC. That will be falling under the category of VLSI. Perfect? Is it perfect?
Yes, sir.
Now, why there is high demand of engineers in this field? What is actually happening? So what is happening? See, earlier devices size was very big. If you remember, I don't know how many of you remember, 1990s kids, they will remember. You remember the size of phone those days? Everyone remember Nokia 6600? I don't know.
Yes.
You are like iPhone
Yes.
generation, or I don't know. At least I am
Yes, sir,
from
we have
90s,
to.
so this you remember, right? A video game type of thing, a big phone it was, right? So that time it was fantasy of people to have 6600, and there was one other phone, Nokia 7210. It will be so big that if you snatch the phone and you want to go and someone is having that phone, they can throw and hit you. Okay, it was so heavy and so big. But nowadays, if I talk about iPhones, you just see how slim, how small, I mean how compact it is. But the complexity and the task is like multitasking right now, correct? You can do a lot of tasks in a single mobile. Earlier it was like if you do 2-3 tasks also, it was getting a hand, right? You're getting it, right? So now if I want to do such kind of algorithm, like multiple algorithm, and then obviously multiple components are required, right? You got it? Everyone is getting it?
Yes, sir. Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Multiple components are required, then size should have increased, right? Because if I want to do, I mean, let's say a single person is there. I am like a engineer, so I can do the task of engineering, right? But someone is not well in my family, I have to take care of that. So for that, I need other resource. I can't do that also. I am not from a medical background, right? And now similarly, if someone is, I mean, going to do cooking, maybe like someone else I can take other resource. That means the resources will increase the more number of component I require. Agreed? So size of that device should increase apparently. That means in 90s, if my phone was this size, then maybe in 2020 it should have been like twice or thrice, right? Yes or no?
Yes, sir.
Ideally, practical
Yes, sir.
scenario. This was the scenario.
Yes, sir.
This should have happened. But if you see sizes, instead of increasing, it is decreasing. Correct? You have seen that?
Yes.
So what makes it to decrease in size?
Moore's
There
law, sir.
comes the terms. Yeah, there comes the terms called as tech node. See, Moore's process and all those things we'll discuss, but I'm just talking about something else. There comes the term tech node, technology node. What is this technology node? We'll discuss that. Hey, don't go on my handwriting and English, these things and all. Just make a note of this thing as per your understanding. We'll discuss more on the technical terms, okay? So when I talk about transistor, I'm just making a small MOSFET diagram and you will help me your understanding. I'll just see that what is your understanding, okay? This guy is, let's say, source, this guy is like drain, and this guy is gate. Okay?
Yes, sir.
If it is P substrate, if I give a positive voltage, then what will happen? It will repel and the inversion layer will happen. Current will flow. Everyone is getting this? Any doubt on this part?
Yes, sir.
No, no, no. Clear, clear.
Okay. So now you tell me one thing. See what is going to happen. A channel is forming here. Okay. This is called a channel. Okay. So with actually what we can do, you can actually take the same transistor and to get the same kind of functionality, we can reduce this channel. So it's like if you reduce this channel, if you shrink this channel, the size of transistor will shrink, correct? And what will be the other benefit with that? The other benefit will be the flow of current will be faster, right? See, earlier you need to travel for 10 kilometer. Now you need to travel for 1 kilometer. Obviously, you'll reach fast here, right? Simple. Displacement is minimum, right? The same thing happening. See, if I keep on reducing this channel, okay, then what will happen? Your device will become more faster and your device will also become smaller, right? You got it, right? Functionality wise, it is not going to change. Functionality remains the same. Yes or no?
Yes, sir.
Yes,
Got
sir.
it? So in same area, let's say earlier in 1 millimeter square, we were able to accumulate 1.5 million of transistors. Now in same area, maybe you can accumulate 2.8 million of instances or maybe transistors, because the size of transistors are shrinking, correct? And this size of actually channel, the channel length actually is defined as technology node. So now if someone asks you like which technology node you are working, so you'll say like 28 nanometer. That means the channel length is 28 nanometer. Is it clear? So if you want to understand more, there is an app called CPU-Z. CPU-Z, I think there is an app. You can download it from Play Store, okay? And if you open this app, it will show you in your processor, your mobile processor, which tech node it is. What is the name of the processor, which company is sponsoring, what is the tech node, everything it will show. Even when you get the good idea of PD after 3-4 months, you will be able to understand that app, what are the things it is showing. It will show the power decimation and everything it will show. You got it, right? So you can try this. So now you got to understand like what is a tech node. What is a technology node, you got to know?
Yes, sir.
So,
Yes.
so everyone should understand currently what is happening. You have reached to a stage where tech node is minimum. I mean, where the device is fastest and the smallest of the size. You know what is the latest technology node in the market currently? Anyone from VLSI background? Anyone from VLSI background?
Sir, I think
Yes,
FinFET
Yes, sir.
14
I think
nanometer
Sweetie
FinFET.
is there. She's from VLSI, I got.
3 nm.
No. Kitna?
3 nm.
7.
7, 3. Lottery lag rahi hai kya? Whatever numbers you will say. Okay. Anyways, so you should be knowing the test chip is already out with 2 nanometer. No, 2 nanometer already it is stepped. I mean, the test chip is done. Currently, 4 nanometer is like happening in market. The QC, Intel, these companies are already taping out in 5 nanometer and 4 nanometer. That means we have reached to a stage where technology is like going to be a very minimum. So what will happen at the end? I mean, if 2 nanometer already achieved, so is it like our technology is failing? I mean, our industry is going to vanish. This is the question that comes in a lot of tech people. They think that, oh, that means our field is going to saturate, and a lot of questions will be starting. So when such kind of questions start and such kind of debates start, I just give them one single answer. In India, is there any fabrication house? They will say that no, maybe one. So still India at least has not started also the market, and you are talking about the closing of market. It's not going to happen, at least in Indian market. In other market it will be, maybe the technology will be saturating, so other things will come. Yeah, one door will be closed, then other door will be closed. And what is the next thing that is going to come in the market? I don't want to discuss that, but yeah, I just coined the term. Maybe you can search and research. So quantum is already there, right? So once particle will be gone, we'll go to the wave, right? So already such kind of research are happening. A lot of papers are there. So don't worry about that. So if a lot of tech people are there, I don't know, in this forum I'm not seeing any VLSI people, but when I take the demo class, a lot of VLSI people will also be joining. So they ask these questions most of the time. So I'm just giving you a hint. don't worry, the technology is not going to at least saturate, the market is not at least going to close in India. Apparently, or you can say in better way, Indian market is now opening in a better fashion. So if you see in past 3-4 months, like 100% placement happened from at least my batch, as far as I know. VLSIGuru has given 90%. So that means market is very good right now. That was not the case before 2 years. So right now, Indian market is really, really good. So don't worry about at least about this market. Okay. So can we move to technical terms now? More. So with this shrink in technology, well, very good. We have actually accumulated more number of transistors in a smaller area, and we have made our device like compact and also capable of doing a lot of things. Correct? This is the goal we have achieved, right? Yes. Say yes or
Yes.
no.
Yes, sir.
Yes, sir.
But what is the challenge? What is the challenge? The challenge is, what do you think? What is the challenge? Power, performance, area. Okay? This is the challenge. So we need to control this thing. The power dissipations, how fast is the chip, performance, what is the minimum size, what can be the minimum size or optimum size of the chip area. So that's why we PD engineers need to be like highly educated in all these terms, so that we can give the best possible chip sizes with the best possible power and area, power and timing performance. Okay, so PPA is something which is going to decide how good your chip is. Okay, clear enough? So that is what you will be learning throughout your course, how to control all these things. Is it clear? Any doubt?
No, sir.
Okay. So now can we start the discussion? How is an ISO? You got a background now. So this was just the background for half an hour. At least you should be knowing what is a tech node, what exactly mean by physical design. So can I summarize this thing? What exactly we do in physical design? Now you get an idea, at least a basic idea.
Yes, sir.
Yes, sir.
Okay. So basically, we don't really make a physical chip, but we just give a layout. That means a map we will give. Like here will be the component, this way the connections and all. That I will tell you more elaborate way in my discussions today. Okay. So now can we start the proper discussion now? Okay. Let's go to the technical things. So if I want to fabricate the chip, or if I want to make a chip, okay. So what should be the first thing that should come in my mind? Anyone fresher in this batch? Who all are freshers?
Hi, sir. Me.
Name? What is the name?
Sachin, sir.
Sachin. Chalo Sachin, I will catch you. Chalega? So Sachin. So let's say Sachin is there. Okay. So I tell Sachin like, okay, Sachin, if I teach you physical design, and after 3 to 4 months, you are going to be a very good physical design engineer. Okay. So what exactly, if you get placed in Qualcomm or Intel or good company, so what is your dream? What is your can you please mute yourself? Can you please mute yourself? Or I will mute everyone. Okay, fine. So I'm telling Sachin, okay, if you get placed in a very good company, what is your dream company, Sachin? At least dream to banalo. Have a dream.
Sir.
Okay.
Intel, sir.
Intel is your dream. Okay. Intel is his dream. Okay. Let's say. So let's say he get placed in Intel after 6 months. Okay, Sachin? So now Sachin get placed in Intel. If he get placed in Intel and he's from very humble background, so what he's saying to me, sir, I want to give a surprise to my mom and dad because they did a lot of things for me. So now I'm placed. Can we give a small surprise? I'll be like, yes, we can give. You go and buy a gift and give them. He's like, no, sir. Actually, technically, we are doing the things. No, so such kind of gift can you make which gives like technical feel also, so that they understand what kind of things I do. I'll be like, okay, tell me what exactly we can do. So he has an idea. He's telling that, sir, we'll do one thing. We'll make a chip. What it will do when my mom will come, okay, and when she is going to enter the door should open and flowers should fall. Correct? No? Isn't it a very good surprise? Sachin?
Maybe, yes, sir.
Maybe. So maybe, I mean, I told about mom, that's why he's hesitated. If I say like Sachin, your girlfriend will come and flower will fall, then it's like more romantic surprise, correct? No, then he's happy. I'm not going to say that. Okay. So yeah, so this is what his idea is. So this chip he want, there should be a chip which will be made, and like if someone is coming, door should open and the flower should fall. That is what he told me. Correct? Now I'm like very highly experienced in the industry, so I can do that. It's like on my tip. I can do that. I can design that. How I can do that? I need to write a logic, and that logic need to be implemented in the physical form. Simple. Yes or no? Everyone is
Yes,
getting this
sir.
point? So how does this chip designing has started? It has started. Sachin has told me one small thing that I will call it as an idea. Okay. So, and the final product will be your integrated circuit. This is what the two things are there. I have to reach from here to here. Correct? Now, what are the things I will ask to Sachin? I will ask him, Sachin, can you tell me like what exactly should be your specifications? That means how, what are the questions I will ask? What will be the size of your chip? Then he will tell that, yeah, I mean, just make a small chip so that others could not see that. Okay. I'm like, okay. He's saying like make such a small chip, it should not be visible from the naked eye. Okay. I'm like, okay, fine. Other thing, he's saying that make a small chip like maybe rectangle in shape. Don't make it like in a other shape. Rectangle is fine. I'm like, okay, fine. Other, he's telling that when she's like at least 5 meters away from that door, then only door will start open. But when she reaches to 1 meter, then flower should fall. You guys are getting what are the things he's giving? He has given some kind of specifications, right? Is it clear till here? He has an idea. Along with that, he has given
Yes,
some
sir.
specification. Like he has given the size of the chip. He is also saying the range of his like sensitivity. So all those things is given an idea, right? So that specifications also he has given. Now I'm like a physical design engineer, but I can't code. I'm not good into coding, right? So any machine, they need to, I mean, given an operation, like if I tell a robot to do this thing, I can't tell robot, hey robot, come here and go and do this thing. Robot don't know English. You got it right. Think of a person like me who don't know Tamil and Kannada, and you start speaking in front of me. What I will understand? Tell me. I will only say Gothilla. Okay. Correct? No. I don't know anything. Same with the robot. Robots only understand the machine language. I am telling English language. Will robot understand that? Yes or no?
No.
It is
No,
not
sir.
going to understand. As simple as that, right? So that means there should be some language in which I need to make them understand. So since ICs, whatever we are going to fabricate, they will be having a lot of hardware structure, and those hardware will be made with along with the, I mean, with the help of the transistors. We have different kind of programming language already in the market. So let's say C was there, C++ was there, COBOL was there, Java was there. So I could have used any of this language and code it, right? See, if I ask you like to code this algorithm, what he told, it's very simple, right? He's telling that if someone is equal to Sachin's mom, then what I should do? I should just first thing I'm telling that open the door, else close it. I mean, leave it as it is, like that I'm telling. You got it right? Everyone is getting it? Then the next part, once open, then what if door is open? If door is equal to open, then what you do? Flower should fall. You got my point. Everyone is getting. This is very simple logic. This way we can write. I'm giving you an algorithm. We can write in any language this thing. Is it clear till here? Is it clear till here?
Yes, sir.
Yes.
But when I want to code this in C or C++ language, C and C++ language, those languages will convert into byte code or maybe machine code directly, but it is not going to make any digital circuitry. You got my point? Everyone is getting my point? Everyone is getting this point?
Yes, sir.
Yes.
So that leads to invention of the language which is going to make the digital circuitry, and they are called as hardware description language. Okay, hardware description language. So this idea and specification need to be converted into logic. Okay, so we call it as a logic design or RTL designing, register transfer level design. Is it clear? Is it clear?
Yes, sir.
And using
Yes.
what? Using HDL. HDL means hardware
Hardware descriptive language.
descriptive discussion कुछ भी हो यार, I don't know actually language. But yeah, see, all these guys who are from MTech background, obviously they would have done this SDL coding. Example is like Verilog, system Verilog, VSDL. So a lot of guys will be here, right? They would have come to attend this PD demo session, but back of the mind, they will be only knowing about Verilog, system Verilog and all. They will be having that doubt also. Should we know Verilog also? Should we learn this VSDL also for physical design? That's why this demo session is there. At least you'll get an idea. And some of you will also get an idea. I can help. See, I'm not in grid like I just want all my guys to come for PD only. If someone is there whom I should suggest for front end, I will let you know what are the parameters in which you can figure out that whether I'm capable of backend or whether I'm capable of front end. I will tell you this front end and backend. Once this session is completed, you'll understand that. Just give me 1 second. I will connect my charger. Seems like it is not getting connected. Till here, just look into the things. I'm just connecting my charger. Just 1 minute, okay? Yeah. So I'm back. So till here, any doubt?
No,
Guys,
sir.
any doubt? No. So now what happened? Once your code is written, so they will use some language I told you. For example, let's say they are using Verilog. So in Verilog, they will write the code, same code. So for example, let's say I'm just giving you a hint. Let's say if such kind of code is written, this is actually simulated, and the tool will understand that it's a mux where select line is there and A and B is there and output is there, maybe something like that. Assign Z equal to something is there. I'm not writing those things. I'm just simply giving. So if you think in this way, so whatever Sachin has asked, if select line is something like equal to Sachin's mom, then what will happen? The door will open. Let's say this is the door open, or else door close. So the same logic, right? Whatever he told, it is going to be converted into physical form. I mean, maybe the hardware form currently. Correct? This is the logic design. So there will be persons who will be writing this code. Those person actually uses the language called as Verilog, VSDL, system Verilog, all this language. In that they will code it. Okay. And once that code is done, and those person are actually called as RTL design engineer or logic design engineer. Is it clear till here? Any doubt?
No, sir.
No, sir, it is clear.
Okay. So once this is done, what exactly we are going to do? We are going to see that whether this code is actually whatever is written is correct or not. Because see, I have written the code, but that code you need to test it, right? Whether that is correct or not. See, if I'm writing this way, module, let's say, and get some name, I'm giving OAB, I'm telling that output O is equal to and I'm giving A comma B. You don't know this language itself, right? So you'll not understand anything. But those who know, they will say that yes, I think that some output A1 is there assigned to some value output O, A and B. This is going to make an AND gate, something like that they are thinking. But is it an AND gate? If I ask this question, is it an AND gate? How to prove? What is an AND gate? What is an AND gate?
Multiplication factor.
Of A and B.
Multiplication factor. Multiplication factor पता है क्या होता है? So if you guys have good English, you use anything, huh? If n is a multiplication factor, it get multiplied to everything. So is it an AND gate? Can I say that? Multiplication factor means one factor that is going to multiply to everything. That is not an AND gate, right?
But if any of the input is low, then
Product
output
of
is low.
Very simple it is. It is a digital circuit where both the inputs are high, will get high. If any of the input is low, that output will be low. Simple, correct? Can I say that?
Yes, sir. This is what I was telling.
That's what. So let's say this is Y, this is A and B. Okay. So that means if I have to test that whether this guy is like actually a AND gate, in A and B I can give this combination, and at Y I can see what is the output, 0, if it is like 0, 0, 1 or not. So if I give the input and capture the output and check that whether output is actually meant for the intended, whatever is required, whether it is there or not, then I can say that yes, my circuit is intended circuit or required circuit, whatever I wanted. Is it clear? Is it clear?
Yes, sir.
Yes.
So
Yeah.
this kind of logic where you write the output corresponding to the input vector, this is called as test bench. So there is something called front-end verification where they will be writing the test benches to test the design. What they will do, they will take the design under test, okay, and they will take the input vectors and they will capture the output, and they will say that whether this test bench, whatever is there, is actually capturing the output exactly the same way or not. If that is the case, it is passing. Otherwise they will say that no, design is like functionally not verified. You got it? So functional verification will happen after the design part. Is it clear till here? Is it clear till here?
Yes, sir.
I will delete this thing. See, this is PD demo class only, but you will get an idea of all the other side angles also. So at least after this class, you'll have a good idea of VLSI flow, at least how it works. So once your RTL design is done, we'll go for the verification purpose. Is it clear? This is called as functional verification. So in functional verification, we can use again same languages. There will be different language called as HVL also, which is called as hardware verification language. So basically, see why this kind of language is needed. You can write in Verilog also. Test benches can be written in Verilog also, system Verilog also. But the problem is right now 2 inputs are there. Assume that 2 inputs are there. So if I have to test the 2 input, how many combination I'm writing?
4.
4. If 3 input, you got to know 8, right? So similarly, nowadays there will be like multiple interfaces, a lot of devices, right? Maybe 1024 interfaces there. Maybe like I don't know, 10,000 interfaces will be there. So for 10,000 interfaces, what will be the combination? You just check it, right? So it's not possible, right, to generate such kind of combination. You got it, right? So that leads to actually evolution of different kind of verification methodologies. One is called as UVM, Universal Verification Machine. There is something called OVM also, Open Verification Machine. There is something called Verification Methodology Machine, something VMM. So these are like front-end verification guys. They will do the verification of your code and they will tell that yes, it is functionally verified. Now you can go ahead and design the chip. Everyone is getting this point? So we will take that code and that code need to be converted into the layout form where the circuits will be visible. Still circuit is not visible. Still only the logic is written and that logic may be converted into 0-1 format and you can see those waveforms. But real circuit is not available currently. Is it clear? Is it clear?
Yes, sir.
Yeah.
So now comes the next part. So next part is, see, for example, Sachin has told me to make the chip, okay, and assume that Sachin was like 2020 batch pass out. Right now he's fresher, but I'm telling just assume that he was going to complete his BTech in 2020. Now it's like 2022, and for 2 years somehow because of COVID or struggle or something like that, he's not able to place. Now in 2022 he got the placement, and he's coming to me and saying that, yeah, I told you like that chip is ready or not. I'm like, man, in 2020 when you told, that time the latest technology node was like 20 nanometer. Now the technology node is like, let's say 5 nanometer. So you want 5 nanometer chip or 20 nanometer chip? You're like, man, I want latest technology only, right? Because technology is changing. Why I will give the older one? Everyone is getting this point, right? So today, if I want to gift someone, I'm not going to buy Nokia 7210 or something like that. Obviously, I will go with the latest, whatever is there in the market. You got it, right? Say yes or no at least.
Yes, sir. Yes.
Yes.
So the code which was written in 2020, whether that code I can reuse in 2022 or not, because the technology is changing. So just let me know whether the code can be used or not.
Code can be used.
We can use.
Yeah. So you guys are really smart. So code can be used, right? Algorithm don't change, yeah. Simple. So if it is like Aryabhatta, that time he has told that 0 into anything is 0. Now also it is the same. It is not going to change now, right? The logic don't change. 2 into 2 equal to 4 only. Even in 1990s also and today also, it is not going to change. Unless and until someone proves that into is something else. You got it, right? Everyone is getting it, right?
Yes, sir.
The logic don't change.
Yes,
So
sir.
logic is same. But that logic, how it is going to be converted into 22 nanometer, how I'm going to use it. Because see, if I'm going to use 5 nanometer, my transistor size will change. Everyone is getting it?
Yes, sir.
So if my transistor size will change, a lot of things will change. For example, tools should be knowing what exactly transistor I'm going to use. Whether I'm going to use this big size wala transistor or small size wala transistor. That tool should know. Correct? And what is this tool? Tool means everything you will be carrying out in called as EDA tools, electronic design and automation tools. On the tool only you will be designing everything. Okay. So there will be softwares or the applications on which you will do the designing. But I think it was open for me. I just now closed, I guess. It is open actually, just now timed out. I will open it. I mean, at the end of session, if some time is there, I will open, no problem. So you got it, right? So there will be EDA tools that will be provided by the companies, and on that only you will be working and converting or simulation, whatever is need to be done, you will do there. Is it clear till here? Can I move forward now?
Yes, sir.
So now I need to tell the tool, or I need to, let's say I need to understand whatever code is there, that code for what kind of tech node, whether it is 22 nanometer or whether it is 16 nanometer, which tech node I'm going to use. So for that, the next stage is synthesis. What it is called? Synthesis. Is it clear? Is it clear till here? I will start from here to here.
Yes, sir.
Again, I will close it in 2 minutes. So see, you will take the idea and specification, you will code it using RTL design engineers. The RTL design engineers will be there, which will be converting your idea into the coded form. And the language they will be using is called as hardware description language. Okay. And the written code or the code which will be coming out from here, that is actually the extension will be .v like this or .sv, because Verilog, system Verilog has this extension. Okay. And this will be called as RTL code, or we call it as a RTL netlist. What is this netlist? That means input output connection. Simple. So RTL netlist. Is it clear? Any doubt? So when this is fed, this RTL netlist need to be fed to this guy. So input will be .v here. Okay. And along with that, I will give some kind of constraints. What is this constraint? What is the normal word constraint means?
Specifications.
Constraints mean specification. That is a contrast word, man. That is different. What do you mean by constraints?
Timing, delay,
Limitations.
power,
Abhi,
area.
whenever I'm asking questions,
Limitations.
please don't think technically. Because my VA will be like, see, technically you can't give answers right now. I'm assuming that everyone is zero right now. Yeah, limitations, restrictions. Can I say restrictions? Are that restrictions only that happens in Indian families? The girls should not go out after 6 o'clock and the boys should enjoy till night. Correct? That is what the restriction is. That is what we also do and you also do. Correct? Our sisters will be there, will say that don't go out after 6 o'clock. Okay, that is kind of a restriction. That is a bad phase of our society. That is the bad part actually. But yeah, that is what happening in nowadays, right? So such kind of restrictions we are putting, right? That is a rule we are making. There some rules are good, some rules are bad. Okay, so that is all called as constraints. So now constraints will be defined for your code also. Why? He has told, Sachin has told that, sir, that chip should be like, it's the my mom should come, and when my mom is coming, door should open. Now tell me one thing, how we will understand that his mom is coming? That question I can ask, because I need to develop the logic. It should not be fantasy. Whatever example I'm giving, it should logically connect. It should not be like some hypothetical thing. Even it is hypothetical only, but some connection should be there to the technology, right? So if I think of this, really if I think, then what I can think, how I can code exactly my mom is coming. If I want that way, if there is something like sci-fi movies, if you think about sci-fi movie, so in that what will happen? Maybe something like that, it will catch the Bluetooth range, and then it will, from that Bluetooth range, maybe it will decode and find which kind of phone she's using, and if it can find some IP address or something like that, such kind of a lot of things we can see, right? You got it. Hypothetically also just match the technology there. So you're getting this point. So that means at least in Bluetooth range only I need to work. Clear enough? Clear enough?
Yes.
Now, if I want to work in Bluetooth mode, I mean Bluetooth range, so what is the frequency I can use? Is there any rule for that? Or I can use any frequency in whatever is there? Or is there any rule?
Yes, sir. Rules.
There may be a rule, sir.
Have you heard about this?
Yes, sir.
What is this? It's kind of parliament for us, right? Correct? Like what we do in parliament, maybe the constitutions will be there, that constitution will be amended and all, right? That happens there. Similarly, IEEE is there, Institutes of Electrical and Electronics Engineers, where what happens, all these kind of parameters are set. Okay, all these rules are set. They will say that, okay, see, if I'm saying that 802.11, they will say, oh, 802.11 is Wi-Fi, wireless fidelity, something like that. So they have defined all those rules. So for Bluetooth also there is a rule. For example, they will say that 2.4 selected 2.45 gigahertz. This is the range for Bluetooth. Just confirm. I am not 100% sure, but if I remember whatever I have learned long back, it is the same range. Okay. You guys are getting? So what is my catch here? What is the catch here? Catch is there will be certain kind of frequency band defined by IEEE that you need to follow. You can't go against that. For 4G, whatever band is there, you need to fall in 4G. For 5G, what is there, you need to fall in that range. Otherwise, it will not work for 4G and 5G. You got it, right?
Yes, sir.
So whatever my data is launching and whatever my data is capturing, that need to be restricted within that range. So that kind of constraints. I just talked about timing constraint. Similarly, maybe power constraint, area constraints also can be there. If I give these two files, and along with there should be some file that should tell which particular technology node I'm using, because for technology node there will be different things. For example, if this is like 28 nanometer, if this is like 10 nanometer, then obviously the channel length, how much it will be 10, here the 25, and other shapes also, the poly, the cut, a lot of shapes will be there. Those shapes and everything will change. You got it, right? So all those things tools should be knowing, like what should be the shape and sizes based on this technology node. That means I need to tell these all rules or these all sets of information in some file. We call it as a technology file. In that, all the rules, all the things related to a particular technology node will be given. This you will learn in detail in when you start the PD course. The first lecture itself it will be taught, but you got an idea at least, because you are going to use a particular technology node now. So that's why you are doing this. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
And other things also. So what synthesis tool does, there is a tool called design compiler. I will talk about the tools later on, but I'm just giving you an idea. There is a tool called design compiler that is from the Synopsys. Synopsys is an EDA company. So that tool actually take these files and they convert into the code into from .v to same .v only, but the mechanism will change inside. So what is those mechanism change? There will be like a lot of optimization also happens there. First thing, see what will be the changes. First thing, if I talk about the RTL netlist and if I talk about synthesis netlist. So in RTL netlist, what was happening? The code was independent of technology. You agree with this? Anyone having any doubt in this point?
No, sir.
But synthesized netlist will be mapped to a technology, right?
Yes, sir.
Okay. Now I am giving constraints here, right? If I'm giving constraints here, so if there is a, let's say, a flip-flop here, there is other flip-flop here, assume that. And in this, if my data is taking some, let's say 1000 picosecond, assume just assumption I'm giving. And in the constraint file, it is defined that don't go beyond 800 picosecond. So tool will try to reduce it to 800 picosecond, right? How it can reduce? Maybe it can reduce the net length, correct? Yes or no? Yes or no?
Yes, sir.
Maybe it can reduce the net length, or maybe what it can do some kind of gate optimization. For example, let's say this is an AND gate, this is a NOT gate. So if these two are the gates, what it is going to make? NAND gate only, right? So such kind of optimization also can happen. Yes or no?
Yeah.
Somehow some kind of optimization will happen. So that means RTL is not optimized, but synthesized netlist is optimized, right? And this guy is optimized with respect to what? Power, performance, and area. Is it clear? Any doubt?
No, sir.
Can I move forward now?
Yes.
So till now, whatever I have taught till now, are we anywhere in the picture? Physical design engineers are in picture till now?
Sir, here our EDA tool is optimizing the code, like synthesized RT.
Correct. We are giving the constraint file. That constraint file will be defining the constraints. What kind of constraints? Like my frequency should be this much. Okay, you can't go beyond this frequency. Or area wise, you can't go this much more than this area. Or power wise, you can't go more than this power. So tool has its own algorithm. Based on that, when we run some kind of commands, those commands we will teach. I mean, you will learn in another 3-4 months. Such commands will be having its own algorithm. It will take the constraints and based on that constraint, it will optimize. The tool will optimize. You don't need to do manually. Obviously, you can't do, right? Millions and millions of gates will be there. How you'll be able to do? You will not be able to do, right? The tool will do that. Is it clear?
Yes, sir. And sir, what is the meaning of RTL netlist, sir?
RTL means register transfer level. Okay, that a good question actually. See what actually happens when you go to, I mean, RTL means all the things will be like in the flip-flop format only, but there will be some kind of cells, for example, means some kind of logic. For example, if I ask you full adder, okay, so full adder, how is a full adder made? Either a full adder will be made using 2 half adder. Okay, I can use 2 half adder. I can directly do a like ORing and I can get this, right? Some kind of logic will be there, half adder, something like that, right? Yes or no? But when it comes to inside half adder, you will find that it is a something like this, correct? XOR will be there and AND will be there, correct? So now half adder is made of these gates. These are called as gate. Okay, these are called as gate, and these are like on the register level, bigger portion. So this will be called as register level, but this is called as gate level. For actually fabrication or for taking through the whole process of physical design also, you need gates, right? Because fundamental building block is transistor, right? You can't directly make a half adder or full adder. Actually, that is also readily available. I will tell you that thing that is called as macros actually. But yeah, the fundamental building block is like we want to make the gate only. What are those gates? AND gate, OR gate, NOT gate, XOR gate. Those things we need to make. That means RTL netlist need to be converted into gate level netlist. So output here, that's what I was going to tell the next point. But since you asked, it's a good thing actually. So this will be like .vg. We will call it as a .vg. So this is a gate level netlist. This guy was simply a RTL netlist. Is it clear now? So all
Yes,
these
sir.
things will be converted into very minute level. That is like we'll go to top-down approach. That means earlier it was a black box where internally what is happening, I don't know. There is two signals and the output, two outputs are coming, sum and carry. But inside it is actually XOR get and get, that we don't know, right? But when it is going to be synthesized, after that you will exactly know what it is inside. Is it clear?
Yes, sir. Yes, sir.
Okay. Let me summarize till here. Then we'll go to our part. So I hope till now at least you got an idea. Maybe whatever rough idea was there, that also will be clear, I guess so. And maybe a lot of doubts also would have come. Not an issue. I will take the questions in the end. I mean, in between also I will take, but yeah, better to take all the question at the end only. Okay. Now we'll just coin the things. See, idea and specification were there. Using RTL design, engineers will convert and write that in hardware description languages. An example was like Verilog. I told that, right? System Verilog, VSDL will be there. Then verification will be done. After that, synthesis will be done. So one important question that is always asked in the industry, I mean, if you go in interview, what is difference between synthesized netlist and RTL netlist? So anyways, I have already given you the, I mean, differences, but when you go through the course, every trainer will teach you. Don't worry about that. Is it clear till here? So now, till now, we as a physical design engineer nowhere in the picture, right? So till now, what it is called, from here to here, we call it as a front end. Okay. So in VLSI, there is something called front end. So these all guys will be called as front end engineers. Okay. And synthesis actually is the horizon of front end and back end. Actually, in some companies, they will call it as a front end, and some company they will call it as a back end. So right now I have just put it into front end, but it all depends on company to company. How they actually differentiate. In some companies, synthesis team is sitting with the front end team. They will say that these are in our team. Like if you go in MediaTek, their synthesis team and their designing team, all those guys will be actually sitting in Singapore. So they call it, okay, synthesis is a front end team. But if come to QC, Intel, these companies, there will be like in backend. So we call it as a backend team. So synthesis is a horizon in between. Is it clear? Any doubt?
No,
now
sir.
can I move forward? I'm moving forward now, right? So now what actually happens? We PD engineer will come into picture and we will do the physical design things. So what we actually do, that we are going to discuss. Can we discuss that? Yes or no?
Sir.
Okay. So let's say the complex chip I'm going to make, that is a Snapdragon processor. Assume that I'm talking about Snapdragon currently. So for Snapdragon, .v is available for me. What is this .vg?
Output of synthesis.
Yeah,
Gate level
synthesized netlist.
netlist.
Perfect. Yes, it's a gate level netlist. So I'm going to use this, and I will go through the PD flow, and finally I will make the chip. Let's see how to make the chip. I mean, I'm just giving you just a word. We'll prove it later on. So now I have taken this particular netlist. Now in this netlist, what are the logics will be written? See, if I talk about processor, what are the things there in processor? What your mobile can do? Simple question. If I'm asking
CPU,
what
ALU, memory.
ये तेरा मोबाइल करता है. What your mobile is going to do? What you can do with your mobile?
Calculation.
Computerization. Compute.
Computerization.
इतना पढ़वैया मत बनो. Photos you can take. Selfies, Insta, you can surf. Correct. Browsing you can do. Video you can play. Audio you can listen. These simple things you can do or not. You can take the call also if everything is done. If your browsing is done, selfie is done, video is done, then you can take call also. So at the end, now mobile is used for call. Other things are priority. Okay. So you can do all these things with your phone. Correct? Everyone is getting this point? That means in my processor, there should be some logic that should actually control the camera mechanism. there should be some set of logic that might be controlling the video mechanism. There will be some kind of logic that might be controlling your audio mechanism. Yes or no? And there will be some kind of logic that is actually converting your network in chip. Let's say an IC, I'm telling that networking chip, NC I can say network chip for calling purpose. So all this logic will be in single set of logic, right? Single set of logic. And this will be like Snapdragon is a big processor. That means like a lot of gate count will be there. So if you talk to total gates in this design, maybe it is possible that it will be having some 50 million instance. If 50 million instance is there, if you start doing, a single person start doing that, he will die or she will die. So obviously I need resources who can actually work on this. Okay. Now anyone can give an idea how I can use it and make it. I mean, is there any way? Think out of the box and tell me, I have to work on this thing. It is a very big design. So how to make it possible to work? What way I can do? Any idea is fine.
Using tools.
थोड़ा सा तेज बोलिए, be loud.
Using tools.
Okay, using tools we can do.
We separate the teams for separate formations. Like for camera process one team and for video another, and we'll combine
Very
it.
good. What is your name? What is your name?
Rahul.
Okay. Rahul has given answer. Separate team we can actually do that. Correct? No, that is what his answer is. And someone was telling some other answer. Can you tell that? Using tool. Okay. See, tool has its own limitation. Yeah. See, for tool, if I want to do all this thing, whatever the flow is there, PD flow, I will teach about. I will discuss about that. That will take a lot of time. Maybe it will take 2 weeks, 3 weeks time. And after 2 weeks, 3 weeks time, do you really dependent on technology? Fully dependent. You should never be fully dependent. You saw in morning only. I connected with iPad and I was like struggling for 20 minutes because that I was not actually, very friendly with that. I don't understand a lot of mechanism. So you should not be fully dependent on technology. It may betray you anytime. So if you're telling tool, let's say tool is working for 3 days and after that something happened, power drainage happened, some power failure happened or something happened in tool only it crashed. So after 3 weeks everything is gone, right? Everyone is getting this point?
Yes.
Or no. So what we can do, Rahul has told the team, actually we can go this way. This is the best way. So not with the team, basically what I can do, I can divide this task. So for example, I will take Rahul now. Anyone want to volunteer me? Just give your names. Give your names, man. I will help you with this concept at least.
Kanika. See
guys, I am not going to, I don't know whether I will take your batch or not. It all depends on slot. But tomorrow when you get to know like who has taught you, will be like thinking, oh, this person has taught me. So at least have that feeling. Finish the lecture today, at least you'll be blessed. Rahul, Kanika, and other, anyone want to volunteer? Just I will use the name, that's it.
Fine, sir.
Sorry?
Sakti.
This is breaking.
Sakti.
It's in Sakti. Okay, that's enough for me. 3, 4 is fine. Okay. And some 1, 2, 3. कोई भी ले लो, एक name मुझे याद है तो I will take it. Okay. So let's say I have taken the 4 names. So I am telling that Rahul will do one thing. Rahul will be handling the audio logic. Whatever logic is there, he will take that. And Kanika, I am telling that Kanika, you will take the video logic. Assume that. Okay. And Sakti, I am telling that Sakti will do that camera logic. And this networking thing, I am telling that Shruti will do that networking thing. Okay. Now what I can do, same logic. This .vg, we can divide into .vg1, .vg2, .vg3, and .vg4. Correct? And this will be like, equivalent to this audio module. This guy will be equivalent to video, this was a camera or an IC, something like that. And then I individually do that, and at the end of the day, I can assemble it. You got it, right? Is it clear?
Yeah.
Yes.
Correct. So this is called as partitioning. So there is the person who are highly experienced in industry. Mostly they will be like 10+ years of experience. But yeah, if you're talented enough, you can get it in like 5+ years also. That is happening in the market. Okay. So 6 years, 7 years experience guy who are really good, they will do partitioning. They will take the full chip They will partition into small segment, not small, at least the manageable. Like for example, 50 million instances there, then each and every instances, module will be like having 2 million or 3 million, something like that. It will take. You got it, right? So such kind of partition we will do. The first stage will be partitioning. Is it clear?
Yes, sir.
So we will do the partitioning. The chip top will do the partitioning. So what was the top? This is the top design, correct? This top design has been divided into small design, correct? Those small designs are called as partition, block, or they will also called as type. So B1 I am telling like this: B1, B2, B3, B4 blocks. So in means VLSIGuru they will be telling block actually. So if you come in like QC, MediaTek, we will call it as a partition. If you go in AMD, they call it as a tile actually, because there is something called, there is a flow actually. They have a tile builder flow that actually does all the things. So tile only they will call it here. So it is the first step, partitioning. So that chip top will do. So our PD flow actually start with partitioning, but as a physical design engineer, as a block level, you don't need to do any partitioning. So you will start doing first stage, that is called as floor planning. What is floor planning? We will discuss that. So FP, floor planning. Okay. I will quickly finish this topic because I will not go deep into this, and because I need to give you an idea and finish up the things. Okay. Floor planning. So what we do in floor planning? So what we do in floor planning? What is the what do you mean by, like, what do you understand by listening this name?
Simply like a civil engineer do in a home, where what should be placed here.
Who has
In
given
the,
this answer?
in the same way, in the die area on the chip, we place the things accordingly, where we should place the cell, where should we place the macros, everything.
Okay, perfect. Any other answer?
Floor planning is nothing but layout.
Perfect. Close to. Any other answer? So whatever Kanika told is like more or less whatever close to whatever I will say. So it's simply, the name itself is saying floor planning. I can at least understand. Can I say it's like planning of a floor? If I don't know anything, at least with this name I can think this way. Achha, planning of a floor, something like that. So if I have a floor area, I need to plan it. And what I need to plan, for example, let's say this is the floor area for me. I have bought a, let's say an area and it's like 1200 square feet, and assume that they are saying like 30 cross some 35, something like that. It is there. I don't know. I took like more. Yeah, maybe it is more. But anyways, it's fine. So now if you take this, in this you need to plan how to place the things. So you need to place the things. For example, I can place my sofa here, refrigerator here, bed here, chair here, something like that. This is also a way. There is also a way where I can place a bed here properly. Maybe my refrigerator will be somewhere here, and my sofa set or something will be in center, and maybe my television will be something here. There are different ways of placing, right? So this way I can plan. So which one is going to give me the best result with respect to routability? That means I can walk properly. And with respect to area usage, there should be no wastage of the area. So that will be like best floor plan for me, right? So that way I can plan and do the things. Is it clear till here?
Yes.
Yes, sir.
Okay, so just I'm giving you a small idea, and probably if you want to understand more, you can go through the YouTube videos and all. You'll find a lot of things, because I don't want to discuss a lot of depth today. I just give you an idea. Okay, can I just quickly close this topic? Yeah. So see, audio module is there, video module is there, camera module is there, network module is there. A lot of 3-4 modules I gave. Let's say I'm taking any one of these. Okay. And going forward, let's say I am taking some network module, assume that. So in this network module, there are like gates. So let's say assume that 1.5 million gates are there. Yes or no?
Yes, sir.
So everyone is getting it? So let's say 1.5 million gates are there, and I'm saying that one particular gate is going to take 0.005 micrometer square. Okay. So if I tell that this is the area of one particular gate, then this particular NIC module or NIC logic, what is the area it is going to take?
1.5 times of
That's it.
0.005.
That's it. This is clear. This much only it will take. Not 1.5 times, 1.5 million times. Yes.
Yes, sir.
Correct.
Please, can you repeat this part?
ये repeat करना है. Good. So I'm telling that network IC module is there. That module is having 1.5 million of instances or gate, and one gate is taking 0.005 micrometer square. Then what will be the total area occupied by that particular module?
Okay, thank you so much. Actually, my network was having the issue. I missed this.
कोई बात नहीं. So 1.5 million into that factor, right? That whatever area. So this is the total area it is going to occupy. So if this is coming x, assume that this is coming x. I'm not going to multiply and give you. Even I can do that. I'm not going to do that. It is coming x. I'm telling that this is like x unit square. Assume that. Okay. So if I give you an area, I'm telling that you can go with the square shape. So in the square shape, I can take the area. This is x unit square. So will this be sufficient for my PD flow or my chip designing? I can design the things in this area. Yes or no?
No.
Yes, sir.
Why no? And why yes? See, for yes, if I take the answer, here like very simple. See, this is the area occupied by this much this object. Then obviously that much area, if I give, the object will come and place there. That is what his understanding is. Now someone has told no. That answer I want. I'm interested. Why?
Yeah, you will be needing the area for the connections.
Exactly.
Because this is the area you took only for the gates that you are placing.
Perfect. So see, can I now explain this simply? Yeah. So now someone who has told yes, it is sufficient. I will tell you. See, in your design, let's say in this network IC, you are having some 10 SRAM and some let's say 1.5 million gates were there. So 1.4 something, 1.499 something like that gates are there. So that SRAM will occupy some area. Okay, those are like big cells. And the small cells will be scattered in your design. You got it, right? So now if I take exactly that much area, the whole area is actually occupied by this object. But how I am going to make the connections? I'm not able to do that. I will not be able to do that, right? Yes or no?
Yes.
Yes.
And even there are a lot of rules. The rules will be like between two different kind of structure, this much spacing you need to maintain. And those rules also you will not be able to follow. Those rules will be defined in the technology file. That means that area is not sufficient, correct? So for that, initially we need to plan and do, start the things in a proper area. So that is what we do in the floor planning. That means we assign the correct area and utilize that area intelligently. Is it clear now?
Yes, sir.
Yes.
Okay. So in floor planning, what we do, we just take the logic, and that logic we are going to actually assign the area for that logic, and in that area we are going to place only big IPs. There will be IPs which will carry out a big mechanism. For example, SRAM is there. Okay, PLL is there. The PLL means phase lock loop. SRAM will be memories. So these things I need to place first. That means all the memories should be placed first. It is same like, see, when you are entering into a room and you want to do the placement of the object, you will be placing the bigger object first, right? You will place your bed first, and then you will place your fridge or refrigerator, then almirah, big things first. Then the small things will come, like maybe a small desk is there or a small chair is there, that will place later on. But first the bigger thing, because that will occupy more area, correct? You got it? So we need to assign those area properly. So that is what we do in floor planning. Is it clear now?
Yes, sir.
Yes.
So once the floor planning is done, we go to the next stage, that is called as power planning. Okay. So what we do in power planning, we need to provide power to this particular object, whatever you have placed. You have placed some SRAMs here, right? Or DRAMs here. Correct? Yes or no? I told you in floor planning you will be doing that, right? So now they need to be provided power, correct? So for power, to provide power, because they need to connect to VDD VSS connection. Yes or no?
Yes, sir.
So to provide power, how to provide power? If I want to provide power supply to a particular area, from where we get the power? In our locality, in our society, how you get the power?
From transformer.
Exactly. One transformer will be there, and from there you will be propagating the power. Okay? Yes or no?
Yes.
Yes.
And if it rains, and this transformer is gone, then what will happen? Complete blackout, right? No power. So this mechanism of providing a single source of power is not good for integrated circuit, right? Because in IC, if there is a single source of power, and if something happens to that, your IC is completely gone, right? Yes or no?
Yes.
So this mechanism is not good. So for that, we need to have a proper mechanism. That's why there is a separate stage called as power planning, where what we do, we will be creating some mesh kind of structure for VDD VSS. Like this mesh kind of structure will be there, and the nearest power source it will tap. Okay, why we need to tap to nearest power source? The reason is maybe it happens like, for example, let's say the power it is tapping from here, that is it is taking power from here, this guy. Think in this way. The thing that it is giving 5 volt, and this guy required some 5 volt. So currently it is getting 5 volt, right? You are thinking this way, yes or no? For the operation, for proper operation, that SRAM requires 5 volt, and your connection is connected to 5 volt only. But do you really think that in real scenario you will get 5 volt? It is connected to a wire. Maybe it may happen that the wire has its own resistance. If it is having its own resistance, the voltage drop can happen, right? V equal to IR. That drop can happen, right? And if that drop is happening and you are getting a 4.8 volt, this guy will not be able to get the correct power, right?
Yes, sir.
So your performance will be degraded probably. So that's why you need to have a proper power planning where your power coverage should be proper. So that is the second stage of PD flow where we do the power planning. Is it clear till now?
Yes, sir.
Yes, sir.
Yes.
I'm just giving an idea. I'm not going deep into that. Believe me, floor planning will take some 3 to 4 lectures. Power planning will take 2 lectures. So you don't worry about that. There are a lot of things in there. I'm just giving an idea, so that at the end of the day, when you go after this demo class, at least you should be having some feel of physical design, and you can Google something. You can go on Wikipedia and check. You can go on Quora and read it. You can go on, YouTube channels and see that. At least you will get now a proper visibility how it is done. That's what the plan is today. Okay, is it clear till now?
Yes, sir.
Yes.
So after your power planning is done, we go for a stage called as placement. So in placement, what we do, see, I told you about the macros, big IPs. This is called as macro. SRAM will be there, PLL will be there, and apart from that, the gates will be there, and gate or gate not gate, that will be scattered. That will be in millions, right? So for this, you'll do manual placement. You'll place it. These macros will be manually placed. Okay, you'll place with your hand, and not with hand, basically using mouse. Okay, but these cells will be like millions and millions of instances. So will you able to be placed all these million instances using your hand? Is it possible?
No, sir.
No.
Meanwhile, let me connect to the tool also. That will help you. Just give me 1 minute. I'm connecting to tool also. Just for your, if you get connection, it will be helpful for you. You'll have a feel actually how it looks. I'm trying, okay? So till now it is going smooth only. Till now the things are going smooth or not?
Yes. Yes.
Yes, sir.
Good. See, my whole intention is everyone should at least get it. At least they should understand whether they are like BTech, MTech, PhD, anyone working also. You don't know any, not a problem. Everyone is on the same forum. Okay. Anything. Even you might have done some research or come back. Believe me, you really don't know anything. when I will start teaching, you will find that a lot of things you have misconcept or things. So assume that you don't know anything. So help each other. Don't be like more depth into concepts, and don't be like very okay only. You ask little bit of better question. It will help others also, and it will help you also. I hope you guys are getting the intention what I'm saying, because see, I assume that some of you already know the things, most of the things, but some of you might have come only for the tool, and some of you are really freshers. So that kind of balance we need to keep in the batch. So every batch I take, there is a mix of that. So you need to cooperate in that way. Okay. So we'll think that you guys are beginner. That's what we will go. Is it clear?
Clear.
Is it?
Yes.
So yeah. So placement is a state in physical design where standard cells will be placed. Okay. And that tool will be doing most of the time. You are not going to do a lot of work there. Okay. Is it clear? Am I audible or not? I think, am I audible?
Yeah. Yes, sir.
Yes, sir.
So what I'm telling, placement is a stage in physical design where your standard cells will come and sit into the core area. This is called as core area, where your logic will be sitting. And your macros you would have placed in your floor planning itself. And after that, your standards, your power planning would have been done. Once these two are done, then you will go for the placement stage. Is it clear? You got it? So in placement stage, mostly it is automated. You will be having a script, and that script will take care of this placement. Is it clear? Is it clear?
Yes.
Yes, sir.
Yes.
Okay. So now, once your placement is done, I'm just quickly moving forward, and then I will summarize like what is this script, and if everything is done with the script, then what is your role? All those things we will take forward. Okay. I'm just quickly moving forward. Okay. So once your placement is done, your standard cells are already placed in the design. Okay. Then we will go for CTS, that is called as clock tree synthesis. What it is called? Clock tree synthesis. Okay. So in clock tree synthesis, what happens? See, your macros are placed, correct? And your power planning is done. Your standard cells are placed. That means you have a lot of sequential cells that are placed in your design now, correct? So for these sequential cells, I need to send the clock, right? Clock is very, very important, correct? Why? Why clock is important?
To synchronize.
To operate in synchronizing manner.
Not only synchronize and not only those things, because your constraints, whatever is given, that need to be met, right? And that you can only meet if your clock is propagated in a proper way. You got it, right?
Yes.
If I want to meet 2.4 gigahertz, then obviously very systematically I need to propagate, right? Otherwise I will not be able to meet that. So for that, there is a separate stage called as clock tree synthesis, where clock will be propagated. Let's say I want to connect to this flop to a clock port. So clock port is there, it is going and connecting like this. Then from here to here, it is taking, let's say, 800 picosecond. I will try to reduce it. For reducing, I need to add buffers. I'm adding buffers here and it will reduce. So adding buffers, how it is going to reduce this value, we'll discuss that, because you might think that if buffer is adding, then buffer delay is 20 picosecond, 20 picosecond, then ideally it should become 840 picosecond. Correct? This is what you can think. But the problem is, if this net is having bad transition, and if you add this buffer, it may act as a repeater. That means it will improve the transition. And that time 800 picosecond can become 600 picosecond. Okay. So this addition of buffers, of improving of this net transition and all these things will happen in the clock tree synthesis, CTS stage. Is it clear? Is it clear, guys?
Yes, sir.
Now the next part, that is the last part, that is called as routing. Okay. This is called as routing, where actually physical connections will be created. If this is my port, this is the cell, I would have created some logical connections here, like the net is showing that it will connect in future, something like this. But in routing, we will be actually connecting with the net. Okay, this is the stage where the actual connection for the signal nets will be done. Fine, very clear till now? And see, I'm just giving you overview. These all stages will require 2 to complete session of 6 hours. to complete that, to do the tools, because tool has a lot of algorithm to do that. You need to understand all those algorithms, then only you will be able to do the things in a proper way. Is it clear till here? Any doubt?
No, it's clear.
No, sir.
Okay, so now this from here to here, it is a PD flow, physical design flow, PD flow. Okay, also called as PNR. PNR means what? Placement and route. See, placement and routing you are doing, so PNR also we call. And also in some companies they will be calling it an APR. APR means automatic placement and route. APR flow, automatic placement and route. Is it clear? Any doubt? Guys, is any doubt?
No, sir, it's clear.
No, sir. Clear.
So I'm just writing again, and I will close this at least these things, and then we'll discuss the other part. So we started with idea and specification, correct? Then what we have done? You need to summarize
Logic
it quickly.
RTL.
Logic design or RTL design. And who will do this? RTL design engineers, okay? And for this, what kind of skill set they should be knowing? They should be knowing Verilog language or system Verilog language. Correct? This is skill set they should know. Is it clear?
Yes.
Then the next part will come what? Verification. Basically, I will call it as a functional verification. Okay? So functional verification will be done by whom? Verification engineers. Okay? Engineers. We call them like front-end verification engineers also. Okay? Is it clear? What skill set they should be knowing? Maybe UVM they should know, system Verilog they should know. If they know this element, they can be a verification engineer. Okay? Once this is done, we'll go for the next part, that is called a synthesis. Okay? In synthesis, the person who does the synthesis, they will be also considered as the design engineer only. They will be also called as designers only, but they belong to the synthesis team. Is it clear? Okay, and what skill set they should be knowing? They should be good in actually timing, that is called as STA, static timing analysis, and they should be also good in design part. That means if you have a good knowledge of Verilog system, it's very good for you. Okay, but if you only know STA, then also you can actually work on synthesis. Is it clear? Any doubt?
No, sir.
Okay, after this, what we have done, we have come to our part where what we have done, partitioning. This who will do? Chip top will go. Chip top owner. We call the person who handle the chip top as a chip top owner. For example, I am like more experienced, so I will be like chip top owner who will doing the full chip. And after this, we will do the floor planning, then placement, then sorry, I missed the, actually power planning is done as a part of floor planning also in some of the companies like MediaTek, Samsung if you go, but the separately I will write here because in QC and AMD they have the separate flow. Power planning, then placement, CTS, and routing. Is it clear till here?
Yes, sir.
Yes, sir.
So this will be completely called as PD flow, physical design flow. Okay, and we will be working on this part. Perfect. Is it clear till here?
Yes, sir.
Say yes or no. So now once routing is done, is our chip ready? Can I say that? Can you give me Snapdragon? You will give me Snapdragon in my hand? No, right? So what is done till now? Till now in your tool only the picture is there. Okay, the layout is there. So after routing, there is something called a GDS2. This is the file, graphical data stream file. Sorry, you are saying something? Someone was saying something.
Routing after verification is.
Wait, sir, wait. Let me complete this thing. Okay. So after routing, there is a file called graphical data stream file that will be available with your tool. Your tool which is going to do PD flow. So that tool is called as implementation tool. So there is two companies. One is Synopsys, one is Cadence. So Synopsys, they are currently using Fusion compiler and ICC2. So ICC2 is a tool that you will be using in VLSIGuru. And Cadence, there is a tool called EDI, Encounter Design Implementation, or Innovus. So these are the tools which you can use for PNR. We will be using ICC2. Even the market is actually predominantly using ICC2 or Fusion compiler, FC. Okay. So this we will be using. Once you complete this flow, this file will be having the layout information. How is the connection? How is the flow? All those things will be there. So we can actually give this file to Foundry. Okay. But there is a catch. The catch is I have done every fixes till routing, but see, for example, I am doing constraint. I'm giving constraint. Based on that constraint, tool is trying to meet the requirement. Okay. So for example, till now you have noted everything, right? Everyone has noted this thing.
Yes.
Yes, sir.
Keep a page. Keep a page blank. Don't write anything there because I need to complete this flow. I'm moving forward. Okay. I need to explain something. Then I will come back to the flow. Okay. Okay. So see, I have given some constraint. I'm giving like 2.4 gigahertz. You should meet launching and capturing. This guy has like there. This guy is a flop. This guy is a flop. There is some combinational logic here, and tool is trying to meet this 2.4 gigahertz. But somehow tool is actually going more than 2.5 gigahertz or something like that. Okay. After n number of iteration, after doing everything, tool is not able to fix because tool has its own limitation, right? So for that, at the end, I need to actually manually fix it, or maybe I can go to better tool which can fix it. You got it? Everyone is getting this, right? So on what parameter I can say that my GDS2 is perfect for fabrication? The parameter is PPA, power, performance, and area. You got it? Everyone is getting this? Say yes or no?
Yes,
and along with this, there will be rule set given by the foundry also. What are the foundries? The foundries are like industry or the companies which are going to actually do the fabrication. Which is the largest foundry?
Sir, I have one doubt. I'm not getting what this graphical data stream file is working.
We'll discuss. Just 1 second. We'll discuss this. So we'll discuss this. Don't worry. We are only discussing that same point. Repetitive. We will complete it in another 5-10 minutes. Okay. So what is a foundry? That is a TSMC. Okay. Taiwan Semiconductor Manufacturing Corporation. A company is there which is actually like foundries are the companies which is actually going to fabricate the chip. Okay. So one example is TSMC. There are other foundries also, like Global Foundry will be there. You have Intel also, which is its own foundry. Okay. Samsung is there. So biggest is TSMC. It's called as king of foundries, you can say. Okay. So they will also give some rule. The rule will be like, they will say that, okay, inside your transistor, whatever shapes are there, okay, let's say this is the shape that I need to maintain. The width of that shape should be 0.4, okay, 0.4 micron. And between these two shapes, maybe they are saying that the spacing should be 0.2 micron. Such kind of rules I need to meet. You got it, right? Everyone is getting it?
Yes, sir.
So these are called as design rule check, DRCs, design rule check. So I need to maintain that also, design rule check also. Okay. So that means I need to sign off. That means I need to complete my requirement of power, performance, area, and also I need to meet these rules given by the foundry. Then only I can say that this particular file is enough and this particular file is good enough to go to the foundry, and then only foundry can fabricate the chip. Okay. Now she has asked the question, what is this GDS2? Okay. So GDS2 is the output file of implementation tool, final stage. Okay. And it is having the layout information of the shapes. Like for example, if this is my area where we are going to do all the PNR flow, like I have done the placement of my macros here. Okay. And I have done the placement of standard cell here. Okay. and everything I've done. But the problem is this macro will be kind of a black box, like it will be like exactly in the rectangle shape. Okay, but in this inside there will be poly, there will be cut, a lot of things will be there. Poly layer, cut layer, metal layer, M1, M2, VRs will be there. All these terms, technical terms, will be taught you later. You will not understand right now, but just understand the internal shapes. Those internal shapes will not be visible in the implementation tool. That it will be visible in GDS2. This GDS2 is called as graphical data stream for information interchange. Okay, this is like a binary format. Okay, so when this file is loaded in a tool called Caliber, you will find that internal structure of each and every shape, each and every macro internal structure. Because when you go through the fabrication process, where you are going to do photolithography, oxidation, etching, you need to understand the internal shape, how you want to make. You got it, right? So that will be available in GDS2. Now you got an idea? What is this GDS2?
Yes, sir.
Okay. Now, once your routing is completed, from that routing database, I call it as a routed database, I need to send the database to timing team. Okay. I need to send the database to power team. I need send the same database to PV, physical verification team. And all this team will check the whether it is meeting the power or not, whether it is meeting the timing requirement or not, whether it is meeting the verification requirement or not. Physical verification, they will check the DRC, sorts, open, all those things. I mean, I'm not going depth into like what is a sort, what is a open, what is a LVS, all those things I'm not telling. I'm just giving an idea. Now you got an idea of design rule check. I told you, right? Like some rules set are there. Like between this metal and this metal, this much spacing should be there. If I'm routing in metal 2, the metal 2 width should be this much. Such kind of rules will be there. Okay, so that means each team, they need to give me the feedback whether I'm meeting or not. If I'm not meeting, we need to fix it. So for example, a timing team is there. Okay, timing team is saying that you have a violation. Let's say you have a setup violation or you have a hold violation. Okay, so I need to fix that setup and hold, whatever is there. Okay, so they will generate some fixes. For example, let's say this net is there. This net is failing setup. Okay, so in setup, if I'm so just understand that. Okay, the constraint is, let's say, 1000 picosecond. That means in 1000 picosecond, whole launching and capturing should happen, but this particular net is taking 1012 picosecond. Okay, that means I need to reduce by 12 picosecond. Yes or no?
Yes.
So what exactly need to be done? The timing team, they will analyze your logic, analyze your circuit, and they will say that, okay, if I add one buffer here and if I add one buffer here, your this 1012 will become 872 and you will meet your timing. So they will give that command set. There will be a file. Let's say they are giving a file timing ECU. I'm calling it timing ECU. In that file, it will be written add buffer on route. Some command is there, and they are telling that this net 1, I'm adding 2 buffers at the location minus location, I'm giving the coordinate. So this file, if you source it, if you source it to again to routed database, this path will be met with the timing. Similarly, if there is any power issue, then some file will be there. If I source it, that will be met. That means I can give this ECOs. ECOs means engineering change order. So after doing routing, if there is any feedback from this timing, power and physical verification team, that need to be maintained. You got it? You got it? So ECO is a cycle in whole PD flow. After your PD is completed, that means your routing is completed, we will have an ECO cycle in our industry. For 1 month or 2 months, it will be there. And in that, we will fix all these issues. Okay, it will go on cycle and cycle. How it will go? We'll go and fix, and then again we will send the database. Again, some issues there, like that it will go unless and until you are finally closing everything. And once everything is closed, the final GDS it gone. I mean, it will go to the fabrication, final GDS. And when final GDS will go to fabrication, this is called as tape out. What it is called? Tape out. This is the final product that it goes. Is it clear till here? Is it clear till here?
Yes, yes, sir.
So all the way from idea till the tape out, this whole flow is called as ASIC flow. What it is called? Application specific integrated circuit flow. ASIC flow. Is it clear till here? Perfect.
Yes, sir.
So what you are going to do as a PD engineer? What you now you would be having some answer at least, man.
There are so many steps. Is there floor planning, power planning?
No, but at the end of the day, what you are going to do? You are going to make the chip, or what you are going to do? You got right now. You would have got right.
We are giving layout and layout.
You are just giving the layout. You are not going to make any chip. You got this point?
Yes, yes, sir. Mm.
Okay. This is what I wanted to make you understand. Just 1 second. Let me just log in once and show you like how it looks in tool, and then we'll summarize the session quickly. 26 of them, which is the file 50. Okay. Ideally, they don't open the tool today, but I open. So 20 server, I don't know whether I'm there or not. Let's see. So there will be different servers. They will tell you. So don't worry about that thing. They will teach you all these things. Since I already having those things, I'm just doing it quickly for you guys. I'll open the tool at least once. So now doubts will be there. A lot of doubts will be there, right? So when you joined this, you would have thought that it's very easy, it's a cakewalk and all. You would have learned from your friends, but it's not like that. It's never a cakewalk, but it's never like a very tough thing also. I will tell you. I mean, let me summarize this session, then probably it will give you a good idea. Meanwhile, I'll just open the tool and show you. At least you'll get a feel. So now, since we have discussed and let the tool open till now. So you got an idea, right? Full PD flow, once it is done, we are as good as, I will try to make you understand in another 5 minutes. See, when you want, so let's say everyone is able to hear me, right?
Yes.
Yes, sir.
Okay, because I'm going to summarize this once. See, it is as good as, understand this way. Let's say you bought a plot, okay? You bought a plot, and that plot is some, let's say 40 cross 40. Okay? So in 40 cross 40, you want to make like a 2 bedroom, okay, 1 hall, 1 kitchen, and maybe 2 washroom, something like that, and maybe 1 guest room. You wanted to make it, okay. So you will directly go to some BTech engineer or civil engineer and will tell that, can you do this? So he will not be like directly starting, and he will not be directly, okay, we'll make it one to start with the bricks and cement and nothing like that, right? First you go to a guy that is called as BR guy, right? That guy will give you the layout. He will tell that, okay, you can have this kind of way, maybe some guest room, you can keep it here, and then probably you can put 2 bedrooms here, okay, and with the guest room maybe 1 attached washroom you can give, or you can give 1 washroom here, so that it will be common for these 2, and 1 washroom here, like that, and then 1 big hall you can keep like this. So such kind of layout he will give, that BR guy, right? So that BR guy, whatever work he is doing, similar kind of work we will be doing as a PD engineer. And the GDS2 will go to the fabrication houses like TSMC and I mean other, like whatever I gave, right? Global Foundry and all. So there it will go. Okay. It has not read. Okay. Open block. Just 1 second. Work. So no one is there from VLSI background. Any other? I mean, see, there are different teams, I told, right? So anyone from any other team? So this is the final database. I will open this final database where routing is already done, and I will show you. Okay, link. Perfect. So this is the tool, right? So this is the tool from Synopsys. This is called the ICC2. If you see, it is written IC compiler 2, correct? So I will go and close this discussion, then we'll come back to the tool. So till now you got an idea, right? How actually, I mean, things happens and how actually you are going to do in a, I mean, work in physical design. So now you might be having a lot of doubt, like, sir, I wanted to do in PD, or should I go in front end, or because you would have thought that VLSI is good. In VLSI, a lot of things are there. It is not only one thing. Okay. So you need to understand whether you are good in your scripting or you good in your programming. If you are very good in your programming and those things, probably you should go in your front end part. Okay. But if you are good in your analytical skill, and if you're good with your circuit and all, then probably you should look into the options in physical design. Currently, physical design is the future, to be frank. Okay. Now, what are the prerequisites? I mean, what are the things you should be knowing? See, you should be good in digital concepts. So these guys will teach you basically digital concept, but you can also learn from yourself also. Okay. CMOS circuitry, if you know basics of CMOS, is also fine. Basically, mostly about the transistor FET and BJTs, all those things along with the CMOS. Then it is very good for you. Maybe short channel effect you can check, because this question comes across to me a lot of, sir, what is the prerequisites? So I tell, okay, if you learn these things, it's fine. So if you know basics of Unix, it's very good actually, because you will be using Unix terminal for this, okay, for working and all. So Unix you should be knowing, okay. And since I told, a lot of things will be automated, placement, CTS, routing, all these things will be actually the set of commands will be there. When I run those set of commands, then tool will be actually working. Okay. So those set of commands will be actually using a scripting language called as Tickle. So Tickle you should be knowing basics of Tickle. So these are the prerequisites. If you learn all these things little bit also, you will be able to I mean learn physical design in a better manner. So I think they have this course. They will tell in the end of the session. I am not going to tell those things. I will take the advanced session. So they will tell you like what is this basics and advanced. I am not going to tell that thing to you. But you got this thing. At least I'm closing this session, so I will tell this thing. Okay. So now coming to this tool part. I'm coming to the tool. So if you see here, this is the tool, okay, which we'll be using. So you'll be connecting with the VPN. They will give you the VPN access and all. So if you see, these are the macros. Big macros are there, right? Someone was asking, who has asked this question? What is this GDS?
Kanika.
Kanika. So Kanika, if you see, if you are able to see what is the internal connections, any internal steps you are able to see here? No, right? Only you can see one blue color something is there, right? So internal steps of these macros will not be visible, but there should be internal, because internally it should be like made with some net connection, something should be there, right? So that thing will be there in your what we say layout view. That is a GDS. So GDS2 is a layout view where you will be having the layout information. You will not be able to open here directly, I guess. You can open in the tool called Caliber. There is a different tool actually. In that you can open. I can try once. Just once I will try. So this is the layout. If you see here, you will find the layout of that particular macro. So if you see that internally, a lot of things are there. Some steps, at least in layout you can see. Okay, but exact internal steps you will find in GDS2. So you got an idea, right? So earlier, if you see, it's like a black box. It's a blue color. But if you open in like go in one level down or something like that, you'll find that internal steps also there. Correct? You got it, right?
Yes, yes.
And if you see this, these are like big macros. But if you go inside, you will find that these are like small cells also. See, these are the cells. If you see this violet color, if I touch this and if you see, this is a buffer. It is showing that it's a buffer. If you want, you will learn tool in some days. So if you open this, you'll find. See this is a buffer. You can find. I selected it and it's a buffer. It's the nbuff x2 HBT. Something is written, but it's a buffer. You got an idea, right? So this kind of small cells are scattered. How many cells are there? Like there will be like 50,000 cells in this design. So you can't manually place it. For this, automated scripts will be there, right? So if you see, I have written some scripts here, okay, and that scripts I'm using for my project, okay. And I will do, for example, if I want to do placement or something like that, anything is there? Yeah, let's say this is like floor planning. If I want to do floor planning, I'm opening it. So if I open it, you'll find that a lot of commands are there. And if I run this command, it will do the floor planning. Everyone is getting it, right? So that means I should be having understanding of these things. So understanding knowledge is important. You don't need to learn how to write it, but understanding knowledge is important. Okay, clear enough? Because you see this way, in companies also, in any big company also, there will be like place.tcl. There will be something cts.tcl. There will be something routing.tcl. So if you source this, placement will be completed. If you source this, your CTS will be completed. If you source this, routing will be completed. If that is the case, if already everything is there, you source it will be completed, then why they are very, I mean, highly paid job, physical design? This class 10th student also can do, right? Yes or no? You got this question?
Yes, sir.
If sourcing by this, sourcing this file, and this file will be written by CAD engineers, computer aided design engineers, and this is like pure proper article file which will be doing all the tasks. If that is the case, then why we need a separate PD engineer? This can be done easily by class 10 12th student guys, right? The problem is tool will not be able to optimize everything, right? So something will be left over, or some error is coming after sourcing or something. So for those debug purpose, for fixing those things, you need human brain also, right? And that also you need a very good brain who has a good understanding of electronics, because you need to understand. I told you, right? If you don't have good concept, you'll be actually I mean end up having mess up the things. For example, I told you this net is there. This net is taking 1000 picosecond. If I want to minimize to 800 picosecond, I'm adding 2 buffers here. And if I tell this way to normal people, they will say the buffer is having its own delay of 20 picosecond. Then ideally it should be 1040 picosecond, right? Why it is becoming 800? Then that time the concept will come. What is a transition? How a transition is going to improve? All the concept will be with the good electronics engineers. Is it clear? Is it clear? So with this,
Yes,
I am signing off my technical session on PD. I will take 10 to 15 more minutes just to give an idea of industry. You will be staying for 10 minutes, right? Or should I close this?
Continue,
Say yes or
sir.
no? Continue. Okay. See, I am like, I will give freedom to you. My lectures will be based on always freedom, like whether you are allowing or not. Because मेरा भी गला बैठा हुआ है भाई. Just 1 second, I will close this topic. So till now it's okay only, right? You guys are getting at least the things. At least you got something.
Yes.
Yes, sir. The best thing we come to know the complete flow,
Yeah,
which was
that's, I
very
mean, I just
important
give
and
it, I
always
just want,
confusing.
yeah, just I wanted to give an idea, because at least once you go from here, you should not be like, I just completely came and started doing PD, nothing like that. So you need to be at least understanding, I mean, the flow. Just give me 1 sec. There is one, I was preparing one video for YouTube, but I didn't posted it. So I will just give that session to you here. It will take some 10 minutes. Okay. Let me know once you are able to see the screen. That I'll share again. You're able to see this?
Yes.
Yes.
yes, sir.
Mahesh, just 10 minutes I will take. After this, all these questions management people will take. I am purely a technical person, so I am not going to answer these questions. This guy will join. Babo will join. He is manager from VLSIGuru. He will answer all those things. Okay, just 10 minutes I will take. Have patience for just 10 minutes. Okay, you will love it. Seriously, I'm telling you, will love it. Okay.
So maybe have your YouTube channel link.
Arey madam, let complete this. Okay.
Okay.
Just 1 second. See, so this is like an ecosystem of VLSI, how it works. Okay. So in VLSI industry, there is something called product-based companies, right? There is something called as product-based company. Example of product-based company, if I ask, let's take an example of Qualcomm. So Qualcomm, what it makes the Snapdragon chip, right? It's basic, like it's like mostly into mobile processor, correct? Famous is like Snapdragon, yes or no? So that is the product. So let's say if these companies, what they do, if they want to make the product, they will do a research and development on that project. What kind of research and development? This research and development will not be only by a technical person. It can be from MBA guys also. There will be finance sector guys also, and there will be technical persons also. What they will do? They will do research. There will be they will be having their own part. For example, the technical person will see that. Can you please all mute yourself? Then I will close this topic. Can you please all mute yourself? Perfect. So now this technical person, they will see that let's say for example you might have heard about like foldable phones, right? The phone will fold, something like that. Whether that is going to actually attract the user or whether that is actually needed or not, that kind of research they will do. Okay, and also they will do that if I'm folding, some kind of internal problems may come or not. All those things technical person will do. What is this MBA guys will be doing? They will see that okay, is there any competitor of the similar kind of product in the market or not? And management people will be there. They will also see that what is the turnaround time, whether it is going to take 1 year or 2 year, or in that 1 year 2 year a competitor company, for example Qualcomm is there, competitor company is MediaTek, so whether MediaTek is going to make similar kind of product or not, and then only they will go and do the things, design part, manufacturing, assembling, distribution, all those things there, and then finally the product will come. Is it clear till here? Is it clear till here?
Yes, sir.
Now the thing is, in this product based company, these are like big company, you also know, right? Qualcomm, Intel, these are like big companies. So they will mostly hire from IITs and NITs in starting. Okay, the freshers they will take from premium college, and they will also give a very high package, correct? So now if they are giving a high package and someone is there, let's say someone XYZ is there, get placed in this company and is getting a very high package. So after 6 months there is no project. So if after 6 months there is no project, they will put some kind of work, normal work, and they will take it in for next 6 months, and then the new project will come. That means only 6 months is working, and next 6 months not the full bandwidth, correct? But the company is paying, correct? So let's say there is a need of 100 people who can execute a task. So 20 they are using their own employee. They need to pay throughout the season. But if I have some way in which they can take 80 employees from somewhere, and they will only work for 6 months, after that I will tell that you can go back, and for those 6 months I can save the salary for these 80 people. So that will be really a good thing for me, right? A good deal for me. If I'm a product company owner, if I have such kind of deal where my own engineers whom I have hired from IIT and NIT, if they don't work for some 4 months also, I can pay them. But if like 100 people are there, it's a bad thing, right? Because those 4 months I don't have any project. So if there is any way in which I can only use some resources for those 8 months, and 4 months I can tell them that you can go back, and after that whenever needed I can call them back. So then it will be a really good thing for my company. Yes or no? Yes or no?
Yes, sir.
So those companies which provide the services, they are called a service based company. What is this company is going to do? They will be having engineers who are skilled in maybe front end, who will be really skilled in back end, so who will be really skilled in some DFT, who is really skilled in synthesis. When this guys is having need of back end engineers, they will take the back end engineers, like physical design engineers. When the guys are having need of synthesis, they will take the synthesis engineer, like something like that, and the services will provide them. So these engineers will go and work for this product based company, okay, for the duration of the project, and after that they will come back to their own company. These guys are ready to pay them for that much amount of period whenever they are sitting. That is called as bench time. In that bench time they will be there. So there will be no big loss for this, any of the company, because service based company will tell this product based company that say we are going to charge you 8 lakh, okay, and this service based company to their employee they will give little less salary, 6 lakh. So 2 lakh they are taking the slippage. Whenever they are on the bench they will pay them. So this way this model works. This is the model of service and product based. Is it clear till here? Is it clear till here?
Yes.
Yes, sir.
So only point is, because these product based companies they hire from premium colleges, they actually take that I mean point in like, okay, if there is any loss also it's fine, okay, but the service, I mean they don't want to hire a lot of people. So that's why you will find that even that's why someone was saying my dream company is Intel, because it's not easy to get into as a fresher. Once you become experienced, it is very easy to go, but as a fresher you can't go if you're not from a premium college. That is a very bad, I mean, thing right now. But yeah, you can't deny with the fact, I mean I can't give you false assurance that as a fresher also you can. There are cases, there are exceptions. I'm telling you from my own batches, at least 35 to 40 students are there. They're working in Qualcomm right now. So it has happened, I mean in the past it has happened, but most of the time they don't hire from non-premium college. That is a harsh reality. A good company, I'm telling. You got it till here? Any doubt? No doubt, right? So now whether it's a service based company, whether it's a product based company, the engineers will be having similar kind of knowledge and similar kind of work they will be doing, correct? So though for those kind of work they need EDA tools, okay. So there are EDA company which will provide the tools. correct? For example, Synopsys is a company, and there is a Cadence. These are like two big companies. There are other companies also. Mental Graphics is there. Caliber, it comes from Mental Graphics. A lot of companies are there, but I'm talking about these two big giant. Okay, so they will provide the tool. Synopsys has its own tool. Cadence has its own tool. So now tell me one thing. There is a new vehicle in the market. Assume that, let's say Kia Sonet is there. So if something happens in Kia Sonet engine, there will be different mechanism, right? Dual clutching is there, DCT is there, automatic is there, IMT is there, CVT is there. There are different kind of mechanism. Assume that. So now if something happened in the latest kind of mechanism, let's say CVT, can you go to the normal mechanic? Will you take your vehicle to the normal mechanic? Give an answer at least.
No, sir.
No, right? You will directly go to Kia guys, right? Because you think that this is the latest something and maybe these guys only know the things. So similarly, when Synopsys and Cadence provide the tool, so for tool, support, any kind of issues happen in the tool, they also will be hiring engineers. They will be called as application engineers, AEs. Okay, and these AEs are really good in scripting and you can say tool knowledge and scripting. Okay, so some of you will be A's also in future. You will get hired as a A's also. There are a lot of my students who are A's because I am good in tools, so they are also very good in tool. So this company will hire them directly. Okay, that is also good. Okay, so at least you got it. So there is product-based company, service-based company, and there is some EDA company also. That example I gave you. Okay, now there is something called as finally semiconductor foundry. I gave you the example. TSMC is there, Global Foundry is there. All those things I told you. Okay, and there will be like sidekicks also. The one which make the wafers, the one which make the mask houses and all those things. So you got the idea like how this whole ecosystem works. Is it clear till here?
Yes, sir.
Okay, just 1 second. I'll go to the next slide and probably it will be finished after that. I hope I'm not taking you more time, right? Okay. So these are some example of product-based company. If you see Samsung, Intel, Scanix, Micron, Qualcomm, Broadcom. So if you see this, like they are like masters in their own field. For example, Samsung. Samsung, you'll find a lot of electronic gadgets, right? Most of the things you'll find from Samsung: washing machine, automatic, mostly automated, and fridge also you'll find, televisions, ACs, a lot of things from Samsung. Correct? Yes or no? Similarly, if you come to Intel, mobile processor, laptop processor, they have not entered mostly into mobile. They are like masters in like CPUs, GPUs, all those things you get it from Intel. MediaTek, it's a competitor of Qualcomm. Qualcomm into mobile chip, MediaTek into mobile chip. Correct? AMD, CPU processor, graphic card, all those things are there. Nvidia, okay, Broadcom, networking chip. No one can compete them in networking, the market of networking. NXP means like automobiles. In automobile chip, no one can compete that. SanDisk, that means memory devices. No one can compete that. So you got it. They are actually masters in their own field. And believe me, in all those companies, someone will be there whom I have taught. So you have that kind of, here also you get that opportunity at least to enter into this company. Maybe as a contractor through a service-based company, or maybe direct employee also. It all depends on your some kind of factors will come from which college, how much percentage, or maybe how good you have done with your training here. All those factors will be counted. I hope you guys are mature enough to understand all those things, right? So, but yeah, be ready to at least target for your dreams. So if someone is having dream Intel, don't worry, that dream can be achieved. It's very easy. Earlier it was a dream, now it is a possibility. Now it is a chances. You got it, right? So these are some examples of service-based company. I can blindly say that everywhere our students are there from VLSIGuru. Don't worry, they will give you the who are selected this year. They will give some list, right? Everyone is, you will find in every company they are there. Not worry about that. Okay. So go through these things once, and these are like EDA companies: Cadence, Synopsys, Mentor Graphics, Synthesized, Silvaco, and P9. So I just gave you a like overview. These are like foundries. TSMC I told like largest foundry. Then we have Intel. They have their own foundry. There are a lot of foundries here. Okay. Yeah, just a brief about this ecosystem of VLSI. So I hope you enjoyed the session, correct? So I will be signing off for the day, and probably Vaibhav will be there from VLSIGuru, his manager there. He will be taking all your questions with non-technical. Okay, technical questions, if you have anything, you can put me, message, or you can tell me. I can give the answers to you. Okay. I'm taking the queries now. You want a break, I can take, but I'm taking queries because even I need to sign off. I have a lot of dependencies to do today. So please quickly one by one, if you have technical questions, please ask.
Sir, which part of PD course are you taking?
Advanced course I will be taking, where we will be starting from floor plan and we do till routing, and in parallel I teach HTA. My expertise more into timing domain. Okay, so I give more emphasis to the timing. So I will teach HTA plus obviously PD is your part. So PD के साथ HTA free है. Don't worry about that. So that two things I will be teaching you. Okay.
Will you also execute some of the projects based on timing and PD like that?
Exactly. So we'll be doing physical design project here. I think 28 nanometer project we have. So in that, what we actually do, we have ICC2, right? I shown you, right? For example, just quickly flash it for you. Just now I was showing you that particular kind of design, right? Just one second. So in that tool only, I will show you, I mean, all the fixes also. So it will be purely practical. If we can take the maybe 1 or 2 sessions also from this guy, they can help you. It will be purely practical here. So whatever you learn here, it's like practical. Okay, it's theory will be there. Anyway, we need to teach the theory. But for example, let's say some net is there and you're thinking that that net is not taking a proper delay. I will show you how to fix the timing. Everything will be taught here. So timing fixes is like something that need to be known to everyone. So that will be taught. Not a problem. You got it, right? Any other question? Or should we sign off?
Name of the mentor?
Name of the mentor?
Yeah.
Any name you want, huh?
The one who is teaching us.
Right now.
Yes, sir.
So, okay. My name is Zia. Okay. So you can find me in Quora, LinkedIn, everywhere I'm there. Yeah. Any other question? I will just put my number here and I'm going to sign off. Maybe you can individually, if you want, you can put a message. Please don't call me. Reason is, see, I can't take all the calls. You put your queries, you will definitely get the answer. Whether you are my student or not, doesn't matter. Okay. You will get the answer at least. So I'll put my number to you guys. If you want, you can ping.
Sir, can I ask one more question?
Please go ahead. Not a problem.
Sir, as PD is a 6-month course, so when will you going to start your session? Like, actually, I am asking this question because I have some problems. Like, I am in my 3rd semester of MTech, so placement is going to start after 4 to 5 months. So that's why I'm asking. When will you start your session, and when we will be able to execute some of the projects so that I can mention all those projects, all those projects in my CV.
I got your question. Just one second. Bebo, you are also there on the call. Bebo, you are there. So I will just call to VLSIGuru manager. Okay, we'll do one thing. I will connect him here, same call. I will be there for 10 to 15 minutes. Okay, and then we'll sign off. I will leave the forum. He will take all your questions, but wherever my thing will be there, I will just tell you. Because the problem is the course duration 6 months. In that they do basics and advanced. In basics, they have the different mentors. I only take advanced. Reason is, I mean, see, someone has asked my name. This is not the right thing to tell, right? I can't tell you the name. I can't tell you where I work. I mean, you guys are understanding those things, right? So I will be only coming as a guest lecturer over the weekend. Okay, I will be only coming as a guest lecturer over the weekend. I will help you. So other way, what they work, they will be able to help you. I am not mostly involved in that. So probably I will just ask them to join. That should be fine, right?
Okay, sir.
Any technical question, I will take it right away. Don't worry. I mean, other non-tech, I think they need to take it.
So whatever projects we will execute, that will be industry relevant or maybe some past projects will be there.
See, industry project, how you can actually execute here? Tell me. There will be that is not a proper way, right? That is a copyright violation. Manohar, can Bebo join or you can join? Tell Bebo to join. I will be there. Yeah. Yeah. So see, no, just let me answer. Finish it. see if industry is there, for example, Qualcomm is there, Samsung is there, that project how you can execute in any training institute. Copyright issue will be there, no? You got it right. Even if you open the file, they will be writing there, this particular file belongs to Synopsys, something misused or something like that, it's a problem, something like that. You got it right. So whatever project you are doing, it's the educational project given by Synopsys, the company itself give along with the tool. There are few institute only in this, see, anyone can learn PD, I'm telling you, by their own way also. But the only problem is the tool. You will not get the proper tool, proper project. So only few IITs and only few reputed institute, they have the connections, or you can say that legal terms with the Synopsys. One is like VLSIGuru out of them. IITs are there, all these NPTEL forum, IITs, and then you have this, you can say RV VLSI, VLSIGuru, only few, CDAC. So only few. So that question, I think you got it right. We can't use industry, but this will be more or less the way we teach. It is exactly the means industry flow. You got it right.
Okay, sir. Sir, we are mostly going to use ICC too.
You will be only using Synopsys tool. So in Synopsys, you have design compiler, right? Design compiler for synthesis. So we will teach here synthesis. See the way I have made this course. What I do, see, right now I took a session where I taught you full flow, right? So PD is the real course that you are going to do, but at least to have a feel, I will be assigning 1 or 2 lecture for synthesis, 1 or 2 lecture for PDN, that is called as power distribution network, power analysis, and in parallel complete STA we teach. But yeah, PT for 1 or 2 session, prime time is a tool for STA. So that means complete flow you will get it, only backend. So don't worry about that. But PD will be like the main course for you. Side mein, it all depends how good you are doing. If you please me, I will teach you everything. That's what I do for every batch. But for every batch, at least I teach one different kind of tool like DC or design compiler basically, or PDN. I mean Red Hawk also we teach sometime. So it all depends on type of batch, type of students there. If you put a lot of efforts, you will get the good reward of that. You got it right.
Okay, sir.
But Synopsys flow, we follow here Synopsys flow.
That is also being used. That is also being used in industry. Like if I got placed in any company where the tools may be different.
देखो क्या है ना, it's like most of the companies, I mean right now I can say mostly company use Synopsys flow, but yeah, some companies will be using Cadence also. But it is same, like if you are able to use Android phone, tomorrow if I give you iPhone, it will take some days, but after some days you will be able to use, right?
Yes, sir.
Same happens.
Nice.
Like my students are everywhere, man. They're working on Cadence, they're working on Synopsys. Obviously we are teaching good here, right? So it doesn't matter. You need to learn one tool and then you will be able to sync with others. You got it right?
Okay, sir.
Any other queries? So Babo, you are there, right?
Can I get your number, sir?
Yes, I'm here.
Already ping कर दिया यार, देख ले. Babo, you are there, right?
Right.
Hello, Babo.
Hello, I'm audible?
Your voice is little feeble, man. Can you be a little closer to your mic?
1 second. Am I audible?
Yeah, I guess you are audible. So now, guys, you can ask any question related to your course, timing, strength, whatever, trainer, anything. Babo will take all those questions. He's manager from VLSIGuru. He will take all those questions. I'm like for technical. I'm done. Okay. You can take the questions from him.
Okay.
You can ask.
Okay. So before starting with the question and answers, thank you, Jaul, for giving the technical clarity. And this is my screen. So I had made some points where you can get
Sorry
the
to say,
clarity.
sir, but your voice is a little bit low.
1 second. Hello, am I audible to everyone? Okay. Jaul, can you make me presenter?
Just 1 sec. I will make you presenter. What name it is coming here? VG something, VG manager, right?
Right.
Make organizer. Organizer is fine, right? You will be able to present also, right? Or can you try now?
Yeah. So screen is visible to everyone? Can everyone see my screen?
Yes, sir.
Okay, fine. So I will just brief about how the training will go, what are the batches, and what are the benefits of doing this course, or what placement assistance that we will provide. So let me just brief about this in 10-15 minutes. Then I can take the questions. Okay. So basically, in this physical design training, it will be a 6 months duration. This 6 months is divided into two parts: 2 months of basics and 4 months of mains training. So how this training will go once you enroll with the course? Once you enroll with the course, we have two batches, that is regular, also known as full week, and weekend batches. For regular batches, it will be a 6 days per week. The timings will be mostly 9 to 1:30, where you are like interacting with the trainer and do, doing all the modules one by one. Now, when it comes to weekend training is had some two structures where we will be providing the basic videos for initial 2 months. The candidates who has enrolled for weekends training, they have to go through the videos, and every Saturday, Sunday, there will be dedicated sessions to clarify the queries. This will remain for only the basic 2 months. Once the advanced training starts, there will be live sessions every Saturday, Sunday, where the sessions will be 9:30 to 1:30 theory, where trainer will be teaching you or guiding you on the projects, and after that 2 to 5 p.m. there will be labs where you will be doing the hands-on under expert mentors. Now, for physical design, a tool like Synopsys tools are required, which is a combination of ICC2, Primetime, Star IC, DC Compiler, Red Hawk. So the complete tool access will be 24 by 7 via remote servers. And now suppose if you are attending the live session, the way today you attended the demo session, this demo session is also getting recorded in the background, and we share the demo session. In the same context, all the sessions that you are attending during training will be shared via our e-learning portal, and every live session you will have access to go through it for a complete a week.
Sorry to interrupt you, sir, but someone's mic is on. He's asked to mute.
Okay, so as I was saying about the recordings, we will be sharing the recorded videos of each and every session to the through e-learning portal that we will create once you enroll with the course. Now, what is the mode of training? See, the mode of training is there are three modes of training. First one is online live training, which is also called as uh, remote learning, where from your location or your hometown itself you can another is offline, that is classroom. We have our brand institute in Bangalore. You can come to Bangalore and attend if you wish to attend it in offline or in classroom mode. Okay, how it will go for regular batches also, as well as for the classroom, offline and online, the training will go in parallel. As of now also we have some candidates who are interested to offline, so from Tuesday onwards the batch will start in offline mode as well as online. Second comes to is e-learning mode. This is basically for the working professionals who are not available as per the scheduled timings, like if they are working professionals 9 to 6, they cannot attend the live lab sessions or live theory sessions. For that people, what we do is we have entire course available in the form of videos. So we will be giving you the entire video. Just one second. Yeah, we will be giving you the login credentials of our portal, where you can access the complete course material, which includes PPT, PDF, session notes, as well as the videos. Okay, and we will provide you the tool access also, which is 24 by 7. So in e-learning, what you have to do is you have to go through the videos and replicate whatever has been shown in the videos. Now, while learning from the video, you might come across multiple doubts. So for that, we arrange dedicated doubt clarification sessions with the trainer, so you can directly discuss. The major difference between online or classroom training and e-learning is, in e-learning you can complete the course at your own pace. If, for example, in digital design, if there are 15 videos, then 15 videos you can complete at your own pace. Okay, this is about the mode of training. Now coming to the post training. See, if I am not wrong, majority of you are joining the course with the objective of starting a career into VLSI or switching a career into VLSI domain. So for that purpose, once you complete the training and you have the expertise on the projects or the training that we have provided, we provide you the placement assistance. Since VLSIGuru started in 2012, we had tie-up with multiple companies. A few of the names I had listed, that is Mirafra, AMD, Perfect VIPs, Capgemini, even HCL. Many more companies are there. We have a good placement record such that we have almost 90% placements in last 6 months. So how the placements will happen? See, during the training as well as after that, every module completion, there will be regular evaluation test. And whenever there is opening comes, if you are performing well in the evaluation test as well as you are completing the assignments that is given by the trainer and the VLSI Guru, then we will forward your resume to the industry. Once we forward the resume to the industry, 6 to 7 days to schedule the interview. Not 6 to 7 days, then at least 3 to 4 days. During that 3 to 4 days, what we do is we conduct multiple mock interviews so that you will come to know what kinds of interview questions are asked. Okay, this is about this one. And now it might happen that candidates it is not possible that in first round itself or the first placement opportunity itself you get selected. So unless and until you get selected or you get a job, VLSIGuru will be supporting you with the opportunities. What is required from the candidate end? Candidate should be practicing whatever training we are providing and should have the expertise. Now, when it comes to placements, the factor comes into picture is package. What package you can accept after completion of this training. See, if you are a fresher who has completed BE, BTech or ME, MTech belonging to any branch, which I mean by EEE, ETRX, Electronics and Communication, Electronics Engineering, Electronics Communication, Computer Science and Engineering, even Electronics and Instrumentation, or even MSc Electronics, MSc Physics. For these branches, all candidates are eligible to take up this course. And if you are a fresher belonging to these backgrounds, in service-based company, you can expect a package of 3.2 to 5.5 LPA depending upon your performance. If you get a chance or if you crack the interview in product-based company, then you can expect a salary around above 6 LPA. Now, there are candidates who has completed in 2017, 2016, or even they have completed in 2019. These candidates are considered as a trained candidates with some educational gaps. So what we do is, if they are applying if they are having relevant experience and if they are doing this course, then the package will depends upon their experience as well as their performance in the interview. Yeah, so these are the points I would just wanted to brief you about that. I would like to add one more point over here is, so as I had just noted, candidates having the BE, BTech or their highest qualification above 2015 can take up this course. Even if the candidate is having till 2013, still he can take up the course. We have other modes of placements through which we can make them provide them support for their placements. So this is all from my end. I will request everyone to put their queries in the chat box. One by one, I will reply to the chat box. Now what happens is, if you will unmute, then it might happen that multiple candidates speaking at one point. So please put up your queries in the chat box. I will address all the questions that are in chat box.
Hello, hello, Vaibhav. I have also joined. I'm Srinivas here. I have also joined. In case there are any queries for me, please let me know.
Sure, sir. Okay, so there are some questions like Sachin. Yeah, he is 2018 pass out. Sachin, yes, it is possible. Even if you are 2018 pass outs, there are companies who are considering 2018 candidates. They are considering that as trained candidates. So even if you are 2013 pass out, whatever training we are providing, you can get an expertise in it. And on behalf of trained candidate, we can provide you the placement assistance. Coming to Jitendra. Sure. Even if you are 2015 pass out, as I said earlier, the companies can consider as a trained candidate. You can also apply. Yeah, Chavez, BTech with electrical engineering is also eligible. Vamshi, yes, the regular classes. What we will do is we will start the regular classes from Tuesday. Tomorrow we will give a 1 day gap for students who wants to enroll for the course, or those who want to have some discussions. But from Tuesday the regular sessions will start. Lokeshwar, your MTech is 2011 pass out. What I will do is I am sharing my number. Okay. So I have shared my number. Please contact me on that. We will check in what aspects we can support you. Okay, so since you are pursuing MTech in final year, you, on the basis of your MTech, it depends on the company to consider your previous experience or not to consider. But mostly after doing this course, you will not be considered as a fresher or a trained. You will be considered as a trained fresher. See, there is a difference between a fresher who is applying and trained fresher. Trained fresher is having the hands-on experience as well as expertise with the industrial tools as well as industrial projects. So after this, you will be considered as a trained fresher candidate. Depending upon considering the experience, it will be up to the company. They can take a decision. Mahesh, there are multiple candidates who are doing their MTech second year and still they are doing the course, because in MTech second year mostly you will be having to submit your project work. So while doing your MTech also you can take the weekend course. Yeah, so even if you join for regular batch, you can switch to weekend training. Even if some candidates enrolled for online training want to switch to offline, or from offline to online, or full week to weekend, candidate is allowed to switch as per their requirement. The only thing is candidate should learn and gain the expertise on whatever training we are providing. Divyashri, the layout classes will be at a different time. It will not be a part of physical design. So we have the layout demo session also tomorrow. You can attend that demo session. Rajiv Kumar, yes, from e-learning to live or regular classes, you can switch. in regular batch, the training will go for 6 days per week. It might go for 3 days theory, 3 days labs, or 4 days lab, 2 days theory. Soumya, even if you are 2019 pass out, after getting trained in physical design domain and having the expertise in the project, definitely you will be getting job opportunities. See, since you are doing masters in MTech and your MTech CGPA is good, what happens is when you are getting trained, mostly your highest qualification is considered. I cannot say that all companies you are eligible, but almost 80 to 90% of the companies will consider your MTech CGPA. Yeah. So as I said, custom layout demo session is tomorrow 7 p.m. Anyone interested to attend the custom layout demo session can attend that demo session also. We will send the demo session link. See, the course is starting from tomorrow, that is, sorry, Tuesday, that is of 10th of May. From 10th of May, it will be 6 months. Yeah. So after during the 6 months, you will be going through the projects, and whatever projects you are going after completion and getting the hands-on expertise, you can mention in your CV, and not even mentioning in the CV, we will guide you and we will conduct even sessions for resume preparation. Okay. See, Ranjan, the major difference between trained students and fresher students is, see, freshers are the pass outs who are having the academic knowledge, and trained candidates are the one who has, during the training, they had worked on the industrial tools as well as aware of the industry standards. Now, the trained candidate will have exposure to work on 14 nanometer. That exposure is not provided to a fresher who has fresh graduate. When it comes to trained candidates or trained fresher, a candidate who has just passed out fresher and done the training from VLSIGuru, definitely it will be having a priority compared to a fresher who has not done any training, because the trained candidate or a trained fresher is having the hands-on expertise. Basically, what we are going to do is in the regular batches, whatever we are covering in the regular batches, that videos will be shared for the weekend students. That weekend students has to go through the videos, and in the weekend they have to clarify your doubts, as well as there will be a dedicated live sessions for the weekend batch. So they will be getting access to all the lectures that is covered during the regular batch, but it will be through videos. Yeah, Rajiv, see, since the batch is starting from Tuesday, till Tuesday you can confirm your enrollment. Yeah, for e-learning batch, you can enroll as per your requirement, but we have a strength of almost 10 candidates, where since we are almost occupied by 80% of the candidates. So I will request, if you are interested, you can enroll as soon as possible. See, as you said that there is a 5 years gap between BTech and MTech. We need to know about the gap details. So as I shared my number, you can contact me. We will go through your profile, and then I can provide you the relevant support. Okay. So anyone having any queries? Okay, Srinivas sir.
Please tell.
Yes, sir. Would you like to add something in this?
No, I think I have. I mean, I was there. I was listening to your responses. It's all. I think it pretty much answers their queries, right? So, if they have any other queries, I can as well answer.
Yeah, sure. So, sweetie, as you said, see, for we will be having a lab sessions that is 4 hours a day. Now, during that lab sessions, whatever the mentors are guiding, candidates are requested to practice them. Now, in order to practice, you need the tool support, tool access. So, the tool access will be 24 by 7. And with respect to each and every student, there will be a dedicated WhatsApp group. Every student will be connected to the trainer individually through the WhatsApp group. We will create a WhatsApp group having VLSIGuru team, the individual candidate and the trainer. So at any point of time you come across doubts, you can directly put up in the group. We will assist you. So anyone having any queries? Okay, so see, the weekend batches, as the training is divided into 2 parts, 2 months of basic training and 4 months of advanced training. In advanced training, there will be on every Saturday, Sunday, the first half, that is 9:30 to 1:30, will be a theory session, and during that theory session, the industrial trainer will demonstrate you on the industry projects, and after the theory session, the lab session will start at around 2:30, where whatever demonstration has been done by the industry trainers, you have to replicate it under the guidance of expert mentors. So while you are replicating it and you are doing the hands-on, the mentors will help you. This is for the advanced training. For the basic training involves digital design, PD basics, TCL scripting, Linux scripting. So these all module videos will be provided to you, and every Saturday, Sunday there will be dedicated sessions for your doubts as well as regarding the modules. Yeah. See, we have our course structure well designed. We will be providing all the presentations as well as session notes. There is no any book recommendation as of such. Whatever we are training, because we will start the training from basic, that is AND gate, ones complement, twos complements, and till the advanced level we will be covering everything, and whatever the prerequisites are there, we will be providing you through our e-learning portal. So there is no as such prerequisites required. Only thing that we expect from the candidate is to have the motivation to learn the things. Whatever training is there, you should have to do. That is more than enough sufficient to start a career in VLSI. Mahesh, yes, we can provide you the recorded videos of Saturday, Sunday doubt clarification also. Yeah. Please feel free to ask your queries one by one. I will address all the queries. Okay. Any more queries? So the timing for the regular batch, it will be 9:30 to 1:30, 6 days per week. Okay. What about after course completion? See, during course completion, we will be conducting multiple evaluation tests as well as mock interview to map your performance. Okay, once you complete the course, you will be adding into a job support group, where until you get placed, we will be providing you the opportunities. See, what we are expecting is a candidate should gain the expertise during the training itself. Now, if the candidate is if want to have the tool access, then the tool access can also be provided. But for that purpose, you have to contact our admin. They will tell you about how the tools can be accessed. Okay, which tools are covered in PD course? See, the tools that we cover is the complete synopsis tool sets that includes ICC2, Primetime, Star IC, Red Hawk, Design Compiler. Okay, so this tool will be provided, sorry, this tool access will be provided 24/7 via remote servers. Yes, you can switch the mode of training from online to offline as per your requirement. Any more queries? No issues, Abhishek. I will be sharing my number in this. You can contact me on WhatsApp. I will check and I will add you into the relevant group.
Vaibhav, I had sent him a request to add to the WhatsApp group. Maybe Abhishek, you can check. We had sent you a link, WhatsApp group link to join.
Yes, every weekend batch, see, we will create a WhatsApp group where the weekend students and the weekday students will be combined. So in case even if you are a weekend student but you are free at a particular day, definitely you can attend it. Yeah. Anyone having any more queries? Okay, so I will be sharing you the enrollment process. Just please be give me 2 minutes.
Vaibhav, you can paste it from that the chat message. I hope in the meantime, before Vaibhav posts the enrollment process, just wanted to summarize. See, during this training, our major focus will be on making sure that you become good with the subject, including all the aspects of PD, that is PD basics and PD main course. Our initially the target is not the job. I mean, that is how I look at it. I mean, we should be focused on getting good with the subject. Once you are good with the subject, it doesn't really matter whether you are from X institute, Y institute, or Z institute. You will get opportunities, because when a company has a requirement, it pretty much goes to all the top institutes. So you will always find it easy to get a job. So we should be initial 5-6 months. We should be more focused on learning the things from a fundamentals. I mean, from the basic concepts rather than memorizing or anything. So our emphasis will always remain to make sure that the learning happens in a structured manner. So once the training is done, so we'll of course provide you with the placements.
Yeah, so everyone, I had posted in the chat box about the enrollment process. So what you're supposed to do is See, you can start the training by paying 5,000. The www.vlsiguru.com/fee transfer is the link for the account details. On that particular account, you can initiate a transfer of 5K, and after you make a payment, you have to fill the course enroll form. That is www.vlsiguru.com/enroll. Okay, once you fill up, you can contact us and reach us on WhatsApp. We will add you into the group, and from Tuesday onwards you can attend the training. See, today class, if you have missed a certain part, we will share you the recordings. Everyone will be getting the recorded video session also. See, the videos or the sessions that we are sharing, it is accessible as it is not downloadable. It is the copyright of VLSIGuru. See, Lokeshwar, what we do is sequentially we provide all the modules. After you complete the basics, we provide you the advanced training also. We have all the projects implemented in the format of videos available. So we will provide you that videos also, but it will go in a sequential manner. Once, if we provide everything at once, students get confused about the line of action or from where to start. So that's why starting with the digital, then TCL, Linux, then PD, then floor planning, synthesis, STA, that sequential procedure we follow.
Shaktivel had one question regarding regular and weekend classes. Yeah, his question is, can I attend regular and weekend class? Shaktivel, ideally speaking, there wouldn't be such requirement where you have to repeat both the things. If that is a specific requirement, we can allow you to attend some of the topics which you couldn't follow during the weekdays.
Yeah, I would like to add in this. See, Shaktivel, what happens is, if you are attending both the class, both the sessions, what happens is, you need some time to do your own hands-on. So rather than, see, mostly what topics covered in regular as well as weekend, it is same, because the content that is teaching and the trainer, it will be the same. So you can attend either weekend or regular, but remaining time you can practice and you can invest that time in practicing or doing the hands-on, so that you can get more and more expertise. Now, while doing the practice or hands-on, as I said, individual group is created. You can directly interact with the trainer as well.
There is one query from Vamshi. See, Vamshi, there is no session tomorrow. Tomorrow will be a break just for course enrollments for completion. The sessions will start from the Tuesday onwards. So my suggestion to you or request to every one of you is that if you are planning to enroll, please do it either today or tomorrow. Because if you miss couple of days, let's say instead of Monday, you do it on Wednesday, you miss couple of sessions. To cover up those 2 sessions, again you will be lagging, because let's say you missed Tuesday and Wednesday session. On Thursday, you won't be able to attend the next session. You'll rather be going through the previous videos. That way, you'll always have that backlog. So, in case you have decided to join, please enroll as soon as possible. Sweetie Baran, yeah.
Right.
One second. I have given a link where physical design training. Please go through that link. That is where you have the complete details about the physical design training, including the schedule, syllabus, the project, what all things we cover as part of the project. And also it has got other details regarding the fee, installments, everything, the course overview, everything is there. If you, after going through that, if you still have any queries, please feel free to call us back. Yeah, Vaibhav, please continue.
Yeah. So coming to the next theory, Mahesh, see, if you want to access particular previous topics, definitely we can provide you. You just have to contact us, and whatever module you require, you inform us. We will provide you that previous videos also. Yeah. If anyone wants to go through the detailed syllabus about what are the topics going to cover, I had shared you the syllabus also. So you can go through this link to know what are the topics you're gonna learn or you're gonna get an expertise. So any more queries, anyone regarding pass out year, placement assistance, course curriculum, or even duration? Please feel free to ask. Okay, so see, I had shared my number once again. This number is available on WhatsApp also as well as call. It might happen that we might not available on call because of some meeting. If we are not responding to your call, please drop a WhatsApp message. We will revert back. Okay. So even if after this session, if you have any queries, you can reach us to via this contact number. Okay. So last that I want to inform is the batch is starting from Tuesday onwards. Tuesday onwards the lectures will start. So the enrollments are open till Tuesday. If regarding the enrollment process or any queries, please reach out to us. Okay, Srinivas sir.
I think we have answered most of the queries. Probably they don't have any other queries. We can end the session.
Sure. So by this, thank you everyone for giving your time and attending the session. We'll end the session now. As I said, do not reach out to me on the number for your queries. Thank you everyone.
Thank you, everyone.